Hi everyone, in this lesson we're going to talk about the type of type query. Now from our knowledge of JavaScript we know that the type of operator is the kind of operator that give us the give us the type for a specific value, what kind of data type that specific value is. So if I were to provide type of hi, this is going to give me string. If I were to do type of 1, 2, 3, this is going to give me number. Now that behavior, we are already familiar with that, and we have already talked about that in TypeScript as well. That type of, it constitutes a type guard in that we guard our type against other types using this type of. And while it does do the same thing in TypeScript, it also has another functionality in TypeScript, and that is why it's called a type query. So it has the functionality, it has the ability to query any type, any data, and extract the types for us. Now, you might be thinking, okay, I already know this type of, do I really have to know type queries and this functionality? And the answer is yes, you have to know that, because there are occasions where we have access to an object for which we have not specified a specific shape. Maybe this object comes from the arguments of a function, or it is a DOM node. Now in this case, how would we go about using the type of this rather anonymous object to type annotate any other object? This problem is something that type of solves for us. We already know that the type of operator gives us the type of a variable in JS, and to your belief, this does the same thing in TypeScript, but it also queries the type for us. So how can we do that? How can we actually query the type? But before jumping into querying any kind of type, I'm going to copy this part, comment it out, and I'm going to save that. And I'm going to come to the log of the browser. I'm going to paste that in, hit enter. Now I'm going to go ahead and I'm going to take a look at the type, of course. Now in the world of JavaScript, if we take a look at the type of an object, it is going to give us an object. If we take a look at, for example, let's have my array 1, 1, and 2. And then if I take a look at type of my array, this is going to give me an object. All right. Now we know that from JavaScript, but in TypeScript, it does something else for us. So I have this object, I'm going to comment it in, and I'm going to take a look at that. Now, let's say we want to extract the shape of this object because we want to type annotate other objects with the same shape. How are we going to do that? Let's say I'm going to call this shape product, and I'm going to pass in here course. Now, if I do that, that is not going to work. Why? Because course, before actually taking a look at that, course is a value. And product requires a type. We have already talked about this. Type aliases can only have types. They cannot have values because they're compiled away. If they have values, it is very likely that we might lose crucial parts of our application. That's why they just have types. Same with interfaces. But if we take a look at that, it says course refers to a value, but is being used as a type here. Did you mean type of course? So it's pretty self-explanatory to why the issue has risen, and what you need to do to solve that issue. So if I use this type of course, now this type of is no longer that type of operator that we know from JavaScript. This is called a type query. Why? Because this type of takes a look at whatever it is in front of it, whatever it is that's in front of it, and it extracts its type for us. That is why it's called a type query. It queries the type of a value. And now that we have extracted the type, before actually doing that, we know that there is an error. If I hover on that, we can see the type is equal to course, which is incorrect. But now if I hover on the type, what do we get? We get that specific type, that object's shape. We get that shape with name, string, price, number, and it is pretty accurate. Now we can use this product to type annotate anything that we want. Let's say we have a product. Type annotated to product, And now the shape of this one is going to be JS. It's going to be the same thing. Price $9.99. So this is what type of does for us. And I've already explained it several times, and I don't really need to explain it again. Let's go ahead and let's jump into our next video where we're going to talk about the key of type query. Hi everyone. In this lesson, we're going to talk about the key of type query. After we have extracted the type of a certain value, we can extract, in case it is an object, we can extract the keys of that as well. And that is what the key of type query does for us. And it's that simple. Now, keep in mind, you must have extracted the type before accessing the keys, because if there is no type, certainly there are no keys. Since we have extracted the type in here, if I hover on the product, we can see that we have a key of name and then we have a key of price. We can extract those as well using the key of type query. I'm going to say type product keys, since we are trying to extract the keys. And then I'm going to say key of product. Keep in mind, I'm not referencing the course because the course is a value. If I reference it here, then that's going to be another error. I'm referencing the type of the course that I've extracted from the course. I'm referencing that. And then from that type, I want to get the keys. And now, if I take a look at that, there we go. We got the name, which is a literal name, literal string key, union literal string key, the other key that we have in the object. So we have successfully extracted the key of. Now, you might be thinking, I'm going to save this first, and we can see that they don't have any they don't have any runtime element. We just see two objects right here. One is course TS, the other one is course JS, because these are strictly types and type related, and for type maintainability and type checking, they don't have anything to do with JavaScript. All right. And now back to the question. You might be thinking, what is the point of doing all of this? Well, the point of doing all of this is going to be visualized when we talk about conditional types and utility types, the upcoming two sections, and mapped types, the upcoming three sections to be more accurate. They play a major role when it comes to making a type completely optional, like we did in our one of previous lectures, one of previous sections. We made a type optional, we made a type read-only. Remember those? Read-only and optional. Now, the key of plays an important role in understanding the source code of TypeScript, in actually coming up with your own types, your own conditional types, your own map types. You can create them yourself by yourself. So it's very, very good knowledge to have, and the basis of this is type of and then key of. That's why I've actually dedicated like a separate section so you can really understand what these are. Now, what we can do is, with this product keys, we know that we have selected the literal key names of this object, so the literal property names. We can also extract, using the bracket notation, we can extract their types as well. So what is the type of name? We don't know. What I mean by that is, what is the type of value that the name property can hold? We don't know that yet. What is we know that in here, but we don't know, we can't see string or number. How can we do that? How can we extract those? So for that, we need to create another type that basically indexes into the product keys. So I'm going to say online product, and I'm going to name it something else. Or I could say product key types, just to be generic. And I'm going to grab our product, and I'm going to pass in here the keys that we extracted, product keys. And I'm going to save that. Now if I take a look at that, there we go. We got string, which is for name, and then we got number. So you can go down and down and down, and you can understand it. You can extract every little thing, every little part of type that this object has with these kind of, we have talked about this, a type query. This is also a type query, but all these three, and this is an indexed access type, this third one, but all these three, they constitute something called a lookup type. And I'm going to give you an example of a lookup type. Let's say we have a function here, and the function is going to say, what's going to do, it's going to get us the course name. And this is a generic function. Now for this, I need to put this down below. Let me put it here, and then let's just put it on the side. That is better. And then what I'm going to do here is I need to pass in a reference to the course, which is going to be this parameter. And since this is generic, I'm just going to pass in t. And then for the info, come on, buddy, t. And then for the info, I'm going to pass in k. Now, T represents the course object, K represents the keys of the course object. And now, what I'm going to do in here is, it's going to be something called a conditional type, where we talk about it in our next section. There's just one keyword where we have seen it so far, but it doesn't typically do the same thing. It doesn't really do the same thing. We saw that when we talked about interfaces and object-oriented programming, but it does something else in here. So for the first type parameter, I'm going to pass in t, which is a reference to our object. Which object that is? In this case, it is the product object. In this case, it is the course object. The second one is the keys. Now, I want this k, which represents the keys of the course, to strictly represent those keys. I don't want it to represent any other keys. So I'm going to say it extends the key of t. What is t? T is the object. And k is the keys of that object. So k must at the least include all the keys from the object called t. And let's go ahead and let's return course info. I'm going to pass in keys right there, course info. Now, again, we are going to talk about extends in our next section further. Just for now, I just want you to be more familiar with that. And this is extremely, extremely intelligent. Why? Because depending on what we pass in as the second argument, it is going to type annotate it automatically. How do you might say, how do you mean? So let's say if I want to grab the course name, I'm going to call this function get course name. I need to pass in a reference to my object, which is this course object right here. And then I'm going to say that give me the name. Now, as soon as I do that, if I hover on the name, see what the type is? The type is string. So in this sense, it knows what it is that we are accessing, because this key of t, this produces for us a union of a string and a number. The string is going to be course name, and the number is going to be course price. Let course price get course name. I should have said like get course info. I think that is better. Let me fix that here as well. Course info. And then I need to pass in a reference to my course, and then which property do I want to get? I want to get the price. And I can log that to the console as well. So log, first get course name, name, come on buddy, course name, and then let's get course price. Let's save that, TS 10.99. So it gave us the course name, and then it gave us the course price. And if I hover on the course price, this is going to give me a number. And this thing, when we combine the key of, the type of, and then this indexed access type, this is called a lookup type. Why lookup? Because we are looking something up, and we are extracting every possible portion or a type associated with that. And we are using it to create these kind of functions that are generic. Now, this function is a generic function. It can work with anything that you want. All right. So I think I'll stop here. We have already talked about a lot of things. And I do suggest, if you didn't really get the idea of key of, the main part was these three things of this section. If you didn't really understand, I do suggest rewatching this video, these couple of videos, and really make sure you really understand what type of does, what key of does, and how these lookup types work. Because if you don't really understand them, then it's going to be very, very much impossible to understand conditional types, utility types, map types, which are really at the core of the language. That's it for this video. See you in the next one. Hi everyone, in this lecture we're going to get started with conditional types. Conditional types in simple terms are like conditional that we have been talking about for values, but they are for types. So it's like the same conditionals, but for types. And you're already familiar with that. I'm even going to give you a very, very simple example. Let's say we have this age, and I'm going to say const allowed to drive, for example, just an example. And I'm going to say if age is greater than or equal to 21, then just go ahead and print allowed. Otherwise, which is the else clause that comes after the colon, not allowed. And we could take a look at that in the console as well. Allowed to drive. Since age is 18, they're not allowed. If the age was like 21 or more, then they would be allowed. Now, we have the same syntax for conditionals for types. And you might be a little bit confused, that what does it really mean, conditional types? Well, what does it mean for values? It means the same thing for types. For values, we say, if you have this value, if you're assigned this value, then I'm going to do this thing. If you're not assigned to this value, then I'm going to do this other thing. Well, for types, it's the same thing. If you are of this type, then I'm going to grab this type. If you're not of this type, then I'm going to grab some other type. So at the end, when we are talking about conditional for values, we're talking about three values. One value is 21, type number. If 21 is true, if this is true, which means that it is 21 or more, at the end of the day, it is value 21, then we print this value. If it is not true, then we print the other value. For types, it's the same thing. If that type is true, then we pass in one type. Keep in mind, with types, there is no values, so everything is a type. Much like in here, everything is a number, there, everything is a type. And then it's going to be one conditional for one type. If that type is true, we do this, we get this type. If that type is false, we get this type. The same thing, but for types. So let's take a look at that. And I'm going to try to explain it in the easiest, simple terms possible, even though I just explained how it works. But conditional types are a lot easier than conditional values because there is just one syntax currently at the time of recording this video. There is just one word that is used for conditional types. So that makes it a lot easier. Let's say I have a type of name. Now, this is not an object. Keep that in mind. This is just a type alias. We know that type aliases could define the shape of an object, or they could define the shape of a primitive data type. This, in this scenario, is a primitive data type. I have a type of name for which the actual type, the name is going to be name, the type is going to be string. And then I have another type for which the name is price, and then the type is going to be number. Cool. So far everything is cool. Now what I want to do is I want to check if the type that I'm accessing is whichever type it is, whether that is of type name or whether that is of type number. So let's take a look at that. I'm going to say type product, and this is where our generics come into the picture because they are generic. That's why generics are really important. And then we are going to say T extends, I'm going to come back to that, T extends product name. Now, this product name, looks like a string, but it is actually a type. So we are checking for this product name. We are saying that if T is at least of type product name, then return the name type alias that I've created above. Well, if it isn't of type product name, then return price. Cool. I'm going to go over this syntax once more. What is this T? The T is the actual, it's going to be either product name or product price, whatever literal type that we are checking against. So you can think of this extends as like greater than, equal, or greater than sign. I know it throws a syntax error, but that extends does the same thing as it did right here, as this greater than or equal sign did. But it is like a word, extends. Again, T has to be at least of type this literal type of product name. And if this entire thing evaluates to true, yes, this is a condition. This is a condition, and the result is going to be a Boolean evaluation, a Boolean value. If this is true, then I'm going to select this type. If this is false, it means T does not exist in product name, or T is not equal to product name. It is something else, whatever. It could be whatever. Then I'm going to grab product price. Now, how is this going to be used? I'm going to give you a very simple example, and then I'm going to just cut the video. Let's say we have a product name. I'm going to type annotated to this product, to this type product that we have there. Product. Now, since we have a type parameter, we require a type argument. Now, here is where the type argument that we provide. Now, for the product name, I'm going to provide product name. Now, if I hover on the product name variable or identifier, what do you think I'm going to see? Well, I'm going to see type string. Again, keep in mind, this is conditionals just for types. We are not talking about values. These are all types. So if I hover on that, there we go. It is of type string. Now, when it is product name, it is of type string. You could say this could be whatever you want. This could be if it is of type, I don't know, like wow, whatever. And then if you pass in wow here, it means this T is wow. And we can see that this wow is at least equal to, let me just get rid of the other one, get rid of this one. So we can see that this wow is equal to this wow. That is why, what do we return? We return whatever comes after the question mark. This is a ternary operator. It's the same thing that we had right here. And if these two are not equal, then we return the thing that comes after the colon. That is the idea of a ternary operator, right? So now that this is not equal to wow, what do you think product name is going to give us? It is going to give us type of number, right? So I'm going to pass in the same thing so I do not lose type safety. And now for the other one, I'm going to say let product price, let's get the product type, and again, we need to pass in a type argument for a type parameter. Type parameter of T requires an argument, right? And it could be whatever. It could be whatever. And it is going to evaluate to number because we have not specifically said that it has to be this. It is the else clause. So within the else, it could be whatever. But for readability purposes and for understandability purposes, I don't know if that is a word, I'm going to pass in price. So I can really know if I do whatever, how can I know what is whatever? So I'm going to pass in price, product price, that is going to evaluate to this. Now in this scenario, T does not extend product name. When it doesn't extend, it means T is not equal to product name. What is T? T is this product name. So the way it works is it is going to come right here, and then it's going to come right here, and then I'm going to remove this and I'm going to pass in. So if these two are the same, then we are going to get the name. If these two are not the same, then we are going to get the price. So this is how it is going to work. For product price, it is going to come right here, and let me get the literal string right here, and then it's going to come right here, and then we are going to remove that and we're going to add equality sign. Is product price equal to product name, like triple equality? No, it's not. So this condition holds false, this is false, and we don't run this, we run the price. That's why this is going to show, now it is any, I'm going to go back, now it is going to show number. And that is it for this lecture, and I'm sure you really understood what extends does for us. Whenever you see extends in a conditional type, think of like this greater than or equal sign. It very closely matches what this does here. It has to be at least of that type. All right, now since this is an extremely important topic in TypeScript, what I'm going to do is I'm going to give you 2 more lectures, and in each of the lectures we're going to talk about 15 examples. They're all going to be types, no values, just types. And in each lecture 15, so there are going to be like 30 examples, so you really master this extends keyword. And that is going to be it. So, and there is one more thing that I need to mention. Under the hood, what we are actually doing with these conditional types is let me rephrase that. Under the hood, these conditional types, they implement the key of type query. And I'm going to show that to you as well. So that is it for this lecture. See you in the next one. Hi everyone. In this lecture we're going to talk about examples of conditional types, and since we are just talking about types, there is no point in the browser, so I just zoomed in, and there is no compilation, there is no nothing, and we're just going to understand how the extends it's going to work. So I have these vague types, vague 1 all the way to vague 15, and we're going to have 15 vague types in our next lecture as well, just to really understand what these are. And there could be a lot more combinations. I tried to get the major ones, and if there are some that you can see in this list, we're going to talk about them in our next lecture. But the formula is going to be like this if you want to check if something has the same type as something else. So let's kickstart this lecture. When we talk about type vague 1, now the result of this is going to be viewed when I hover on the type name. Then we are going to know. So if this part holds true, we are going to see true. If this part basically produces a false value, we are going to see false. So first thing, the first one, high, which is a type of string. Keep in mind, these are all types. They're not values. So you need to think of them like that because they're not values. They're just types. High, which is of type string, extends string. Is high a part of string? Yes. String is a general part. Like of all the possible strings in the world, yes, high is a string. So high at the least is a part of string. The type of high and the type of string is the same. So if I take a look at the vague 1, we can see we get true. So the first one is cool. Now you know how we are going to move forward. Now, does high extend any? Yes, it does. Why? Because any represents all possible values. And out of the all possible values in TypeScript, a large subset of them are strings. Any represents all strings, all arrays, all objects, everything. So yes, it does include high. So there we go. It returns true. So far, everything is cool. But does high extend number? No, because this is of type string, and type string does not, at the least, equate to type number. So this is going to return false. What about the other way around? String and high. Does string extend high? No. Why? Because we know that, we can see that high, it might be like a little bit confusing, but I'm going to explain it. We can see that high is of type string, but string is not at the least equal to high. We have all possible strings. So within all possible strings, we have high. Yes, we do have that. but we also have hello. We also have how are you? We have how are you? These are not included in hi. So we are trying to fit something extremely large into something extremely small, which is not going to fit. That is why we are going to get false. What about number? Is the number 13 extend the all possible numbers? Yes. Out of the all possible numbers in TypeScript, one is 13. That is why it's going to return true. But the other way around is going to be the same thing as for strings. Because number does not extend 13. Why? Because in number, we could have 14, 15, 16, 100, 200. They're not included in 13. That is why this is going to give us false. Let's take a look at Vec 7. Does all numbers at the least have the type of all strings? No. These are numbers, these are strings. So we are going to get false. But what about any? So out of the all possible values in TypeScript, all numbers, strings, arrays, everything, are numbers one of them? Yes, they are. Number at the least is a part of any, because any provides us with everything. So even the smallest thing, like 0.0001, which is like a very small number, that is part of any. And like the big int, like a big integer, that is also part of any. But what about this? Does a string extend a number? No, they're completely of different types. So we're just going to return false. Let's move on to 10. Now you're getting what this extends does for us. This is a conditional. What about true and Boolean? Out of the all possible values of Boolean, which are just two, true and false, is one of them true? Yes. If I explain it in the other way, is true at the least has a type of Boolean? Yes, it does. So we're going to get true. What about true and string? No, completely different types. So we're going to get false. True at the least is not a part of string. But what about Boolean? Is Boolean at the least a part of any? Yes, because any encompasses all types, everything. That is why it is true. What about false? Yes, it encompasses false as well. So it is going to give us true. What about strings? So out of the all possible values, did we do this? String any, string number, string high. I don't think we did that. Yes, out of the all possible values for any, one large subset of it is string. That is why it's going to give us true. But what about 13 and any? Yes, out of the all values for any, one of them is 13. That's why it's true. So that is it for this lecture. In our next lecture, we're going to take a look at some other types like the unknown, like the void, undefined. These ones you might feel like they're missing because I didn't want to bombard you with a lot of them in one lecture. So let's go ahead, let's move on to the next lecture and let's see how they are going to play out. Hi and welcome to the second part of conditional types examples. In this one, we're going to talk about 15 more examples that I've tried to be as diverse as possible. Of course, there are so many other conditions, but my suggestion is do not go over the board with this. I think these 30 are going to be enough. Just move on from this topic. The more you dive into it, the more confusing it might get. So when you understand the concept, just have enough practice and then move on. Don't waste too much time on these. So that's why I'm just like giving you 30 examples, and I think that is enough. Let's go ahead and let's talk about the first one. Unknown extends any. We have already talked about the any. Any is all possible values. Here is also all possible values, all possible values, I keep saying values, what I mean is types, all possible types. So of course, unknown is one of those possible types. We're going to get true. For Vec 2, we are going to get true, true, and then true. Yes, all possible values are part of, I just said values. All possible types are equal to all possible types. Let's talk about this. What about undefined and void? This is going to return true because fundamentally, undefined is we don't know the value, void is we don't know the value. We don't know the type. So it's going to give us true. Undefined and never, it is going to give us false. Why? Because never is like something that is never going to be achieved. So it's like an empty box. And undefined is, even though we don't know what it is something, but we don't know what that is. Never is nothing. So something is not part of nothing. Nothing is part of something, but something is not part of nothing. That is why it is like false. Undefined and unknown, they're going to be true because undefined, fundamentally, we don't know the type. Unknown, we don't know the type. Null and any, yes, null is a part of any, so we're going to get true. Null and never, it's going to be the same thing as undefined and never, false. What about never and never? Of course, an empty box has at least the type of another empty box, so it's going to be true. But about unknown and never, didn't we just do this? No, that was undefined and never. So it's going to be the same thing as with undefined. This is going to be false. And the final 4 ones are about arrays. So an array of strings, does it have at least the type of all the possible arrays in TypeScript? Yes, because of all the possible types for arrays, we do have an array of strings included in there. That's why it's true. What about an array of strings and an array of all possible strings? No, because within all possible strings, even though there are all possible strings that you can think of, there is not one single of them that is an array. They're just like singular values or types. That is why it's false. But what about this any? What do you think this is going to be? Well, this is going to be true. Why? Because yes, out of the all possible types that any could represent, a type of string, a type of number, a type of Boolean, a type of array of number, array of string, array of Boolean, yes, one of those could be a type of array of strings. That is why it's going to say true. But what about number and an array of anything? Yes, within an array of anything, we could have an array of number. That is why it's going to be true. So that is it for this lecture. See you in the next one. Hi everyone, in this lecture we are going to talk about the extract utility types. Utility types are built-in TypeScript types that on a fundamental level implement conditional types. And we're going to talk about 2 utility types, the extract in this lesson and exclude in our next lesson. Extract built-in type, a built-in utility type, is used to extract a subpart of a type based on a certain criteria. And the part that we extract is actually the part that we need. But in the case of exclude, it's going to be the reverse. First off, let's take a look at this. Since these are built-in types, and we're just talking about types, there is not going to be any JavaScript compilation. There is not going to be any browser. It is strictly TypeScript. The first one that I'm going to do, the first type is going to be type strings. Let's say from this mixed types, I want to grab type. I want to extract the ones that are strings, like hi and like hey. Now, since this is a built-in type, there is an actual keyword for it that says extract. And we can see the actual definition of it, that T and U, T is the bigger type, U is the type that we want to extract from it. So it says extract from T those types that are assignable to U. So the syntax is going to be generic, no surprise there. We are going to pass in the big type, which is mixed types. And then what do we want to extract from there? Let's say we want to extract all the strings, and this just did. It extracted all the strings. In simple terms, what it did was it's extracted everything that is a string. Very simple. Now, if I hover on it, what are those? They are hi and they are hey. And you can see that this is a union, and that is for a good reason. Now, if I hover on this, we can see the actual definition of it. So if we find the types that we're looking for, we return those types. Otherwise, we return a type of never. And what is this extends? This is a conditional type, and we talked about it a lot, so I'm not going to go over it again. Now, if you want to take a look at the official source code, just control click or command click, and there we go. Extract from T those types that are assignable to you, and here it is. This is the official definition. In our next lecture, we're going to talk about this exclude. Let's go over some more examples. Let's say I want to extract from this type all the numbers. How can I do that? Well, it's done in the same way. What I could do is I could just copy this, put it down here, and I'm going to change the string to number. Now, if I hover on it, we get 13 and 666, right? Because they are the only strings that we have there. Let's say I want to extract a product. And what is going to be the type of that product? Now, the type of the product could be this TS, JS, or Python. Now, what I'm going to do is I'm going to specify a specific type. I'm going to say name, which is equal to type TS. And if I hover on it, there we go. It got us. Now, keep in mind, this name TS is no longer a value here. This is a type. And you can see it's being type annotated there, and the price is of a general type, which is number. Cool. We can also extract it in the following manner. We could say price, give me all the types for which one member's name is price and its type is number. And I'm going to call this products, since this is going to give me more than one product. There we go. It says name TS, price is number, name JS, price is number, name Python, and then since 11.99 falls into the category of the number, it gives me Python as well. Now I'm sure everything's clicking for you. But what about in, let me just, I'm going to call this products array 1. We are going to talk about arrays. What about an empty array? Does it include an empty array? No. So when it doesn't include, we get a type of never. Where is never coming from? Let's take a look at the definition. We can see that if we extract the type, if we get the type, we return the type. If we do not get the type, we return never. That is why if I hover on this, it has returned a type of never because it doesn't exist there. That is why it is of type never. Let's take a look at another example. What about an array of strings? I'm going to call this product array 2. Do we have an array of strings? Yes, we do. And we return that. It looks like a tuple, but it is actually an array. What about an array of numbers? Do we have that? An array of numbers. Do we have that? Yes, we do. We have this array right here. So it is going to return it. If we didn't have it, then it would have returned that never, because that is in the official source code. And with this, our lecture comes to an end. See you in the next one, where we are going to talk about the exclude utility type. Hi everyone. In this lesson, we are going to talk about the exclude utility type. The exclude utility type allows us to get the subpart of a type by specifying what we do not need. By excluding the types that we don't need, we will end up with the types that we want. So it's like the other way around. And since this is a built-in utility type, there is actually a syntax for it. There is a keyword for it. And we're going to go over that. Let's go ahead and let's get started. Now, the first type that I'm going to grab is going to be not strings. So give me everything that is not a string. Exclude. There we go. And again, this is like a generic type. First off, we need to pass in our type, big type, and then we need to pass in u, the type that we want to extract from there. And let's say string. Now, as soon as I do that, in the case of extract, it gave us all the strings. In the case of exclude, it's going to give us everything except for strings. So if I hover on this, there we go. So we got here, we have some values there. Let me take a look at that. we have these objects, and then we have all the values right here, and we have like a couple of values here, up there. So we can't see strings. That's why it's called not strings. Let's extract everything that is not a number. So I'm going to say not numbers. Let's take a look at that. There we go. And now here we have a string. There is one string there. Where is the other one? The other one is right here. What about if we want to do the same examples? So let me just open that up right here. Let's say we want to grab everything that doesn't include a property that has a type of TS. We could do that as well. So I'm going to say name TS, give me everything that does not have a property of name with the type TS. So I'm going to say not product. Yeah. If I hover on it, there we go. Name TS is excluded. The rest of them are included. There we go. Everything. We could also say, give me everything that doesn't have everything that does not have a property of price. The same example as previously. Like this. Let me just write it so then I can explain that. Not products. Give me everything that doesn't have a property of price with the type of number. So it's going to exclude all these three objects. There we go. So we have this array of TSJS 13, this array of numbers, string, and then this number, and then another string. Well, we could also say that give me everything that is not an empty array, like that. So not products array 1. If I take a look at that, I'm not sure if this name is intuitive enough, but it's going to give us everything that we have. Come on, buddy. Why when I hover on it, it goes away? So it is everything that we have. There we go. We got the arrays and everything. We could say, give me everything except for an array of strings. We could do that as well. Not product array 2. And now we got everything but an array of strings. The array of strings that we had there. And we can certainly do the same thing for number. And let me convert that to 3. Let's take a look at it. There we go. So, and now you can see in all these cases, what we ended up with was a much larger type than what we filtered out. So that is what exclude gives us. So if you want to end up with a larger type, you're going to use exclude. For example, within your type, you have 100 different type definitions. And you want to maybe select 90 of them. So you're going to exclude 10 of them. Because excluding 10 types is easier than extracting 90 types. But if you have, like, let's say 10 types, and you want to only have to use 2 types from there in a specific part of an application, then excluding 8 types would be more difficult than extracting 2 types. So this is how you can go about this. At the end of the day, if you extract, you'll end up with that. But if you exclude, you'll remove that, and whatever remains, you're going to end up with that. So you need to know what does which. And I just explained where you can use which. That is it for this one. However, I need to show you this as well. The actual type definition. So we are going to exclude from T those types that are assignable to U. So if this condition holds true, we are going to return never. We're not going to select it. Otherwise, we're going to select it. So we're basically checking for a never, right? So with this, our lecture comes to an end, and see you in the next one. Hi and welcome to this lesson. In this lesson, we are going to talk about some prerequisites which are necessary to understanding map types. Now, these prerequisites, we have already studied them. I just want to combine them all into one lecture and just review them. The first concept that I would like to talk about is the map method that we have on arrays, because the map method clearly provides us with a very good mental model in understanding mapped types. The idea behind the map method is the actual word of it, the actual name of the method map. The actual map term refers to transforming one thing into another, and specifically it refers to changing similar items into a different list of transformed items. How would that work? I'm going to talk about it in the context of a console log. Let's create an array. Let's say we have these 5 numbers, and I'm going to map over all of the items within this array. And in each time, in each iteration, I'm going to do something with an array item. Now, what do I want to do? First, I need to specify as a function parameter. This is going to be the loop agent, like that I that we have in a for loop. And then we are going to say that this item word is going to be like 1, and then it's going to be 2, and then it's going to be 3, depending on iteration. And then what do we want to do with that? Let's say I just want to get this item and I want to convert it to a string. So I'm just going to say toString. As soon as I save that, we are going to see that we have our array, but now all the numbers, they are strings. And the map method, it returns an array for us. So we selected all of these, we mapped them one by one, and then we converted them, we transformed them into something else. That is what basically mapping means. And that's how map types actually work. This is like a good mental model to understand map types. The second concept that I would like to talk about is going to be the indexed access type. First, let me name this map method. The second one is going to be indexed access type. And we know that with an index access type, we can access the type of a key from an interface or from a type alias. Let's say we have this type, and I'm going to call this our regular product type. We have a name with the type of string, and we have a price with the type of number. And I'm going to save that. Let's say we want to extract the type of the name property using another type. That is what an indexed access type does for us. I'm going to say course name, and I'm going to grab our product. The only way we can index into a type is using bracket notation, and I'm going to get the name. And if I hover on the course name, this is going to give us a type of string. So this is an indexed access type. The final concept that I'm going to talk about is going to be index signatures. Index signatures. Now, index signatures are a little bit similar to map types, and I'm just going to review them, and then we are going to have another lecture where we actually talk about a map type versus an index signature. So I'm not going to emphasize too much on index signatures in this lecture, just a review. So let's say we have a type of product. What an index signature gives us is that for an arbitrary key, we can have a specific type. So for an arbitrary number of keys, we can have a specific or predefined type. That arbitrary key could have any name. You could say K, which specifies a key, but you need to specify the type of that arbitrary key and then the type of the value that that key holds, which is going to be string in this case. And I'm going to say const product, type annotated to product, and now we could have a product TS. I'm going to say TS bootcamp. We could have a product called JS, and we could call it JS bootcamp. So for an arbitrary key, we can have as many values, as many key values as we want. And this is what index signatures help us accomplish. That is it for this lesson. See you in the next one. Let's talk about map types versus index signatures. Consider this type. It's called course, and this type is used to define the shape of an object that has two properties: name with the type of string and a price with the type of number. Now, if we were to create an index signature that would allow us to have as many courses as we want, we would go about it in the following manner. We're going to say product, and I'm going to make this generic, so just to make everything a little bit more interesting. And what I'm going to do is I'm actually going to create a dictionary for which we have a key, and the value for that key is going to be a specific object. It's going to be an object. Therefore, we're going to end up with a dictionary. Now, the key name itself, the literal key itself, doesn't really matter, so I'm just going to say K, but the type of it matters. So we have an arbitrary key of type string that holds a value of which is an object type. So therefore, we end up with a dictionary. Now, since this is generic, I don't want it to be this course. I want it to be anything possible. So what I'm going to do is I'm going to grab my type parameter and I'm going to pass it right here. And now our generic works. And it is able to work with any kind of object. Let's go ahead and let's create a function. I'm going to create a function that is going to get the course info. And this function is generic, where we pass in our type parameter. Within the function definition, we are going to have one parameter that is going to be of type product. And then whatever the object it is that we want to include as the values for the keys, that is going to be the T object. And we just want to return the specific course. Everything is making sense so far, right? Let me just bring this down. Let us create a courses object, and I'm going to invoke this function, get course info. Get course info. I could say get courses info, since they're plural. And then what this function is going to require us, it's going to ask us to provide an argument for the parameter course that has a type of product. But since we have not specified what we're passing here, we can see that the T, so far, it has been evaluated to unknown. Now let's go ahead and let's fix that. Now, if we want to fix this unknown from here, since this is a generic function has a type parameter. For a type parameter, we need a type argument. And the argument is that course type that I've created right here. And now if I jump into this function again, it is no longer unknown. It says course, and it says course right here as well, since I've passed in this argument for the type parameter. Cool. Now let's see how we can actually work with this. Now, since we are working with this function, we need to pass in a product. This product that has a type of T. The product is right here. So I need to have keys that could be anything, as long as they're of type string. They could be any possible string, but their type has to be string. But the values, they have to be of type T, which in this case is course. Now what I'm going to do is I'm going to say course underscore 1. They're going to go snake case. And let's add a name property, since we need to have a value that it has the shape of this course. We need to have name and then a price. Name is going to be TS. I'm going to keep it short. Price, come on, this is not string. Price is going to be $10.99. This is one. Since we are dealing with an index signature, we can have as many keys as we want. And I'm going to say course number 2, course number 3. For this one, the name is going to be JS. For this one, it is going to be Python. Now, this is how an index signature works, and a map type is similar to this, but it is going to be a little bit different since that is a map type. Now, even though index signatures, and let's just take a look at the transpile JavaScript, we just have a simple function and an object literals that we basically pass into that function. Now, when it comes to index signatures, we are extremely flexible. This could be, the key could be course 1, it could be product 1, it could be literally everything, and we could literally add as many courses as we want. Now, what if we don't want to create as many courses as we want? What if we want to be a little bit more specific so we can keep track of what we have in our database. Now, what I'm going to do is I'm going to convert this into a map type. So I'm going to copy that, comment it out, and I'm going to come down here, and this is going to be a mapped type. And this is going to be our very first official map type that I'm going to talk about. Let's jump here. So what I'm going to do is I'm going to convert this part into a mapped type. Now, you need to keep in mind before actually converting that with a map type, we are sort of dealing with the behavior, of a for loop, but for types. What I mean is that when we effectively loop over the keys of the type with a mapped type. That is why I talked about the map method in the previous lesson, because the map method of arrays is a good starting point to understand what map types are and how they work. Let's convert this into a map type. Now, keep in mind what it is that we want to do, what kind of an issue it is that we want to solve. We basically want to limit how many courses we can add. We want to limit it to a specific number of courses with specific keys. We shouldn't be able to say course 1, or we could say whatever here and it is going to still pass. Now, we don't want to do that. We want to restrict ourselves a little bit. So what I'm going to do is I'm going to change this definition right here, and I'm going to convert it into a map type, and then we're going to go over it. So since we're dealing with courses, in each iteration, we are going to deal with one individual course. Think of this course word, this as the I in a for loop. And then again, this isn't a singular because in each iteration, we just deal with one course. And then course n, what it is that we want to iterate over. How many courses? 2, 3, 4, 5. We need to be specific. That is why we want to work with map types. Now, in this case, I want to be able to add a TypeScript course and a JavaScript course, but not a Python course. So I'm going to say TS is allowed or JS is allowed and nothing else. And this type of it is going to be course. So I'm going to remove the generic nature from here. Let's remove that. And since I've removed that, I need to remove that from the function as well. Let's remove it from there, and let's remove it from there as well. So everything is working fine now. Let's remove the generic argument from here as well. Now, as soon as I do that, there is an error. It says course 1 does not exist in type product. Why? Let's first understand what this line is, and for that, I'm going to zoom in a little bit so we can really understand. Now, you need to keep in mind that with a map type, we have specific property keys that we want to use. But with an index signature, the property keys are arbitrary. And we saw that in this previous example, arbitrary, but in this one, we have specific property keys, which is one TS and the other one is JS. Now, in an index signature, the name of the property could be anything. But in a map type, one of the most important parts of a map type is something that we're going to use in our object. What is going to be that thing? In other words, what is going to be the name that we're going to use? So in this case, I am strictly relying on using TS, which looks like a string, but since it is being used in a type alias, this is a type TS, and this is a type JS. I cannot have a value other than a string of TS stored, type annotated to this TS type. We know that. So this is an extremely strict literal type. We have already talked about them. So how this map type is going to work is that we have two different keys, and each time when we want to generate a type for these keys, we are looping over this union type. So in the first, you can think of it like this, like in the context of a for loop, because that is sort of what happens. Course in the first iteration is going to have the value of, is going to have the type of TS. So let's add it right here. It is going to be type of TS. I'm just going to add it there. Very good. And you can see that has been satisfied. And then when it has a type of TS, what is going to be the type of the value of TS? That is going to be of type course. And there we go. It has a type of course. And in the second iteration, the type of course is going to be JS. So let's change that to JS as well. And it is going to be assigned to as a value an object. And what is that object's shape? It is a shape this course. And that is it. We are done with this looping. Therefore, this course 3 is not going to be anywhere. It doesn't exist. It's not going to exist on the product. We are only able to specify known properties. So what I'm going to do is I'm going to get rid of that. I can no longer specify something that is not within this union type. Of course, if you want to add that, you need to add it within this union type, then you can add it there. This is how a map type works as opposed to how an index signature worked. And think of this in as the for in loop, like for const something in something in regular JavaScript. It is going to work in the same way, but you need to be very, very mindful that this is strictly type information. We're not dealing with values here. So there is not going to be an equivalent of this in the compilation. If I take a look at this transpiled JavaScript code, there is no equivalent of that. So everything is going to be compiled away. It is just another type-safe way for us to create objects and to just make sure we have no type errors and we are extremely strict. So if I do TS instead of that, if I do TC, there is going to be an error. So we have to be extremely strict. And if I do, even if there is like the slightest typo, that is going to be caught. And then we are going to end up with a very, very strict type system. Now, in case you're wondering, if I convert this to an index signature, will that work? Let's convert it to an index signature. So what I'm going to do is I'm going to say that course could be a union type of TS and JS. And there is just one error. So compiler is not going crazy. That is good. We just have one error. And the error is exactly where I've implemented my changes. Now, if I hover on it, let's see what it says. An index signature parameter type cannot be a literal type or generic type. And then this part is extremely important. Consider using a mapped object type instead. So this is something that the index signature cannot handle. And I'm going to provide it with a comment signature so you can know that this is an index signature and this is our mapped type. Let's save this, and I'm going to comment this one back in. I'm going to zoom out a little, and we can see that everything is still working, but now we have like a more fixed and inflexible kind of object that is very, very good. That's going to be very difficult to have any kind of bugs in. And there is one more thing that I would like to show you, that if you were wanted, we saw that we cannot convert this map type to an index signature. We can have an equivalent of that in the world of an index signature. But what about this index signature? Can we have an equivalent of this index signature in terms of this map type? Yes, sort of. We can have that. So what I'm going to do is down below right here, I'm going to copy this line. I'm going to put it right here, and then we are going to talk about how we are going to create a map type for that. And I'm going to call it something else so it's not in collision with this one. Type product clone. I'm not sure. And then what if we want to create the equivalent of this? Well, what I mean by equivalent is that it can work for an arbitrary string, arbitrary number of strings with arbitrary names, not the generic aspect of it. So the way that we are going to go about this is that the same thing. We are saying that our course could be in the entire strings, And let me just put that inside an object, and then at the end, what we want to do is we want to assign a value of course to whatever the course is. So when I say course in string, what I'm effectively trying to do is I'm trying to iterate over all the possible strings in TypeScript, which is not possible. Well, sort of not possible. And this in and of it itself says that this is not like a strictly looping behavior. We're just talking about strict types and just getting one type and assigning it a value, a type of a value. Because there is no actual and real world way of iterating over all possible combinations of strings in the entire world. There is no way to do that. But this index signature has an equivalent of this map type, and it is going to work. And out of all the possible strings, one of them could be TS, another one could be JS. So these two could be equal. Now, we did create an index signature for this index signature, this map type, but we could not create an index signature for this map type. We couldn't have that, but in this case, we do have that. And I'm going to keep it right here so you can really understand it. And I'm going to comment out everything. Usually I do that off screen. In our next lectures, we are going to talk about several different types of map type and why they're important, what are their use cases. We're going to go back and forth a lot into TypeScript declaration files like source code, and we're going to really understand how TypeScript leverages these map types and how they are implemented, how you can create them, and why they're created, what is their advantages, so everything around that. That is it for this lesson. See you in the next one. Hi everyone. This is the map type that we created in the previous lecture. In this lecture, I would like to make it converted into a generic map type, and so it would work with any property key, not just TS and JS. And after we're done, we will end up with our very first official map type called the record mapped type. Let's go ahead and let's see how we can do that. Now, I'm going to complete this into perhaps 3 different iterations so you can see the process of how I'm going to convert something so rigid and inflexible to something flexible that could work with any kind of object that we want. So you can see this is the original, and I'm just going to call it original mapped type, and then below it I'm going to have first iteration, and then we are going to have second iteration. So in the first iteration, I'm going to copy this commented out, and I'm going to come down here. Now I want to make it a generic map type. So first off, what I would like to do is I would like to change its name from product to something else. I'm going to say, since we are working with a record map type, I'm going to say record type. Keep in mind, type is like uppercase. It's like TYPE uppercase. So there is a difference between this type and the record type that is inherent to JavaScript, to TypeScript. So we are not having like any kind of naming collisions. So that part is done. Now I want to convert it into a generic. Now, what are the 2 different kinds of types that we have? We have a type for our keys, and then we have a type for our values. So effectively, what we have is we have a key type, comma, value type. For every key, we provide it with a certain value type. So everything is making sense here. Now, we still have this thing that is not generic. It's very specific. So I'm going to get this course. This course basically represents a key in an object. So I'm just going to convert it to a key. And then we need to basically call the keys of an object. And that is going to be key type. So for key in key type, and for every key type, what I'm going to assign it to is going to be the value type. Everything is making sense so far, right? Now assignable type string number. We're going to come back to this, and we're going to fix this as well. So don't worry about it. This is going to be our very first iteration. Let's go over it one more time. We changed the name from product to record type. Since we're dealing only with key types and value types, we added them as generics. Now, instead of adding T and U, I've provided them with like a little bit more specific names so you can really understand what is happening. And then in this part that looks like an index signature, we basically iterate over all of the keys. What are all of the keys? All of the keys are key type, and we iterate through them using this individual singular key. And for every key that we get, we assign it a type of value type. So everything is working correctly. The only issue is right here, that this key type, so far, TypeScript doesn't know what the type of the key type is. What types does it hold? Is it a Boolean? Is it a string? Is it a number? Is it another object? What is it? TypeScript doesn't know. And we need to provide TypeScript with some information as to what this actually is, what category it derives itself from. And that error is basically saying that. So what I'm going to do is I'm going to copy this and I'm going to comment it out, and then we are going to jump into our second iteration. In this second iteration, we're going to specify that this key type extends all strings. What does that mean? It means the type of the key type could be all possible strings that we have in JavaScript, in TypeScript. It could be anything. And among those, we have TypeScript and JavaScript, TS and JS, these ones right here. So now you can see the error is fixed. And let's go ahead and let's put that on this line, and I'm going to put this brace on the other line, and I'm going to save that. Let's go over this and let's really understand what we are doing here just one more time. So now we are restricting the key type to only be of type string. And congratulations, you just created your very first official map type, which is called a record mapped type. The record map type constructs a type with a set of properties which are key type of type value type. The extends in this scenario means the same thing as it did when we talked about conditional types. When we say key type extends string, what we mean is that whether or not every key type is part of all of the available strings in TS. For example, if I have two different keys of type string, name and price, are those part of a general data type that is string? Yes, they are. Now, keep in mind that there are many hundreds of thousands of more strings in TS, but that doesn't matter. What matters is that our specific keys must exist on type string, and it is not a requirement to have an infinite number of keys to satisfy the string. As long as we have one key that is of type string, or we have several keys that are of type string, the extent is going to be satisfied, the type is going to be satisfied, and everything is going to work. And now I'm going to show you the actual official map type as well. And it is going to be something like this. We have type record, and we have a K that specifies the keys that extends key of any. We are going to come back to key of any and what that is. And then we have a value type of T. P is going to be the key that which is going to be the property or the key in our type in K, and for every property we assign it a value of T. Now you can see there is clearly an error, but these two are almost identical. We have key type right here, and then we have this key that looks into all of these key types. There we go, P and K, and then we assign it a value type, which is this T. We have just given them like a little bit more specific names. Why is there an error? The reason that there is an error is because this same thing already exists in TypeScript. Record is a reserved keyword. So now if I hover on it, you can see duplicate identifier record. Record was also declared here. So I'm just going to click on it, and there we go. Here is the actual TypeScript source code for the record map type. Construct a type with a set of properties K of type T. K is the key type, T is the value type for every specific key, and P is one individual key that we use to iterate over all the keys. That is very simple. And here is the official. Since this is throwing an error, what I'm going to do is I'm just going to comment it out so you have it as a reference. And you can see both of these are the same. Now, what is this key of any? We know that the key of gives us a union of all the keys, but this key of any, this any doesn't mean everything in this context. Let's take a look at what that actually means. What it actually means is a key that could be of type string, number, or symbol. It can be anything else. And how do I know that? Let's take a look at it. So what I'm going to do is I'm going to say record key type. This is my variable. And I'm going to type annotate it with key of any. Type annotate it. There we go. And as soon as I do that, let's hover on the name. What is the type? String, number, and symbol. So the types of keys in a record map type could be only of type string, number, and symbol. Since we are mostly dealing with strings, with keys that are of type string, TS is a string, JS is a string. In our previous lecture where we talked about these ones, course 1, course 2, these snake case identifiers or property names, they were also strings. So we are generally talking about strings. So that is why I just removed this key of any and I just restricted that key type can only be of type string, nor number nor symbol, because that is more common. Other than this, these two are identical. And I'm going to put this within this comment as well, so you have it as a reference what this key of any means. Again, key of gives us a union of all the keys. We have already talked about that. It's sort of like it is a type query, but we end up with a lookup type. And now there is an error here that says cannot find product name. And what I'm going to do is I'm going to change this to record type. And as soon as I do that, now since this record type has two different, I should have probably like comment this one out, copy it down below so you can have that original function. And I'm going to work on this one. Now, since we have two type parameters, this is one, this is the other, we need to have two arguments. Record type. Before passing the arguments here, we need to pass them here, and we need to really understand what it is that we want to do here. So within the function, what I'm going to do is we need to pass in a value for the key type, an argument for key type, and an argument for the value type. So I could pass in T and U, and I'm going to say T is going to be the type, T and U. If I hover on it, it says T does not satisfy the constraint string. I'm going to say U extends key, U extends string. Let's just extends string. T doesn't, this type parameter might need an extend string constraint. Oh, I actually written them in reverse. T is going to be the value type, that is okay. And I just need to change their places. I'm going to delete that. So the first type parameter is going to be the key type that extends the string, and the second one should be the value type. And then I'm going to pass in T here. So it's going to be U, and then we're going to have T here. And now we can see all the errors are gone. If I hover on this, U extends string, we can only have of type string. And then we have this T right here, which is going to be the value type. We could change these with the names that we have provided here, so they are more understandable. Key type extends string, but since we have it right here, I don't need to like go and make this function extremely verbose. And in here, we need to pass in, we could just make it infer that, which is going to be perfect. And you can see that it has already inferred that the record type is going to be of type a union of TS and JS, which are literal types. And then what do we have here? We have price name and price, which are union type. There we go. Here they are. So you don't really need to provide it here because TypeScript can infer that extremely well. There we go. You can see we have type TS and JS. So if I just provide it with a TS and with a JS, now I would be restricting myself from adding anything else. So I could add Python here, and I could just assign a value of this object to it. Let's say Python, and let's say the price is going to be 11.99. Now if I hover on it, we can see that the Python has been added as a union type. So instead of making this all of these types, writing all of these types here, we just let TypeScript infer that. And since we have created this record type, we have created the actual type, annotated this function with it, and we have created the actual type, it is okay to let TypeScript infer it in this scenario. Because otherwise, I would have to copy all of this, and I would have to put it within the function argument, within where I have actually calling the function. So I need to put it everything right here. Let's put that here. Let's save that. There is an error, and there we go. The error is gone. Let's save that, and you can see this is extremely unreadable. So I'm just going to let TypeScript infer that, and you can see it is perfectly fine because everything has been type annotated correctly. TS, JS, and Python. And if you add another course, you're able to do that, but you need to follow a certain criteria. And I guess that is going to be it for our record mapped type. In our next lecture, we have started right here. We have actually started right here. If you remember I think it was the previous section where we talked about utility types. And now we talked about the record type. In our next lecture, we're going to talk about the pick, and then read-only, then require, and then partial. And then that's it. Then we're going to wrap this section up. So that is it for this lecture. I'm going to keep this file open right here so we don't have to go back and forth, and we can just see the source code, how that code has been arranged. So that is it for this lecture. See you in the next one. Consider this interface. We have an interface type of product with 4 properties. Now, what if I just want to use 2 properties? I want to have name and I want to have rating. How am I going to go about that? And are there going to be any kind of errors? Let's take a look at that. I'm going to get the name, assign it to TS, and I'm going to get the rating, and I'm going to say perhaps it is 4.6. Now there is an error. It is saying that we are basically missing some properties, but that's the point. I don't want to miss them. I just want to have an interface. For example, it has 100 properties, but I'm only interested in a few of them. And how am I going to go about that? Well, that is where the map type helps us. The pick map type helps us, and it helps us by selecting some properties from a type and excluding the rest. Now, how are we going to go about this and creating that pick map type? I'm going to go ahead and I'm going to create it right here. I'm going to say type pick. We're going to use the same naming convention as I did for the record, pick type. And in here, there are actually 2 things that I need to specify. I need to specify the type and then the keys that I want to select. So the way that pick map type is going to work is we need to supply it with the type, which in this case is our interface, and then we need to tell it which keys we are interested in extracting from the interface. So we need to provide it with 2 things. One is going to be the type. The other one is going to be the keys of that type. Now, how are we going to go about that? We need to specify that the keys belong to that type, or the keys are part of the type. So we're going to say extends. And then since we're strictly talking about the keys, we need to use the key of operator as well. And which type? The type that we pass in right here. So everything is making sense so far. And then we need to iterate over the keys and select only the keys that we're interested in. So we are going to say key n keys, and for every key Now you need to keep in mind that when we are selecting the keys from a type, what are we actually trying to do here? We are effectively indexing into that type, be that an interface or a type alias. We are indexing into that type. And when we index into something, what is that called? We have already talked about that. It is like several sections back. It is called an indexed access type. Why? Because that is the only way that we can index into a type and select the keys that we want. So what type it is? Now keep in mind, when we worked with an indexed access type, what did we do? First, we referenced that specific type, and then we selected the keys that we wanted to extract from it. There we go. The type of the keys that we wanted to extract from it. Now, since we created that, the reason that we created it like this is because we want this to be generic. We don't want it to be specific. We want our pick type to work with this interface and 1,000 other interfaces. That is why we are using these kind of upper keys. You could just say key, like if I take a look at the record type, I did say key type and value type. I could basically use the same convention right here and create it and work and just convert it into this one. So this is going to be our, but this is like our type, and I'm going to lowercase this to type. And let me put this perhaps below that. I don't actually, let me try to make sure these two look the same. So we have a type, we have keys within here. So this is going to be key type, correct? Extends this type, which I'm going to do type. All right. And then we have here our key type. Let's put that here. Let's add the K. And then we still reference the type, and then we select the key that we want from there. Lowercase ey. And I think everything is working perfectly fine, right? So we have a type, and then we have key types that have to be within that type. And when they are, we iterate through those keys, and we index into that type using the keys that we are interested in. Now in this scenario, we don't have this value type. We are not necessarily, we don't want to add like a value type to it. We want to index to get the type of those keys. Cool. And I think that is cool. So let's modify this product as well. I'm going to change this to this pick type. I'm going to put the pick type right there. And as soon as I do that, since I have two type parameters, I need to have two type arguments. The first one has to reference the type, which is going to be product. And the second one should be a union. As you can see, we're using extends key of, which gives us a union. It has to be a union of the types that we want. So the type of keys that we want. Which key types we want to grab the name, and we want to grab the rating. And let's grab them. Now keep in mind, these are string literals. The actual name is a string literal type, and the rating itself is also a string literal. The type of the value that they hold, in one case it is a string, in the other case it is a number, which we are not interested in that. So it's going to be name and rating. And as soon as I do that, all the errors are gone. So if I hover on this, we can see we only select name and we only select rating. And we can log it to the console as well. Let's save that, and everything is working perfectly fine. So this is an example of a pick type, pick map type. I'm going to comment this one out, put it down below, and I'm going to now get rid of this type. And now it is still going to work because this pick, now here, this is the actual source code pick that TypeScript has. So if I just hover on it, you can see we got basically the same definition here. And we could jump into it, and there we go. Here is the pick. So I'm going to select this, copy it, put it down below right here so you have it as a reference. Let's get this, just bring it down here. So how are they the same? We have a type, and we extend from that type using this K, and we look within the K using P, which we have done here. And then from that type, we get the P, which are the properties, the type of properties, and we have done the same thing here as well, key. It is just, this is like a little bit more readable version of what we have in TypeScript. So both of them are going to work, and I'm going to comment that one out. I'm going to comment this one back in. And I think we are done with this pick map type, but there is something else that I want to show you here. All the other three that we're going to talk about in our upcoming lectures, they're going to be like a modification of what we have in that pick. So in this scenario, we make everything read-only by adding a read-only access modifier. In this scenario, when we have this negative sign and the question mark, we know question mark makes everything optional, but if you add a negative sign in front of it, it makes everything required. And even though here it says optional, this is the partial. The actual name of the map type is partial in this case, but it makes everything optional. And you can see that there is just a question mark, but in fact, there is actually a plus sign there as well. So I did just add that plus sign, and I'm going to save it. And well, Prettier is not going to pretty this for some reason, but there is no error. You can see there is no error anywhere, 0 errors. So if you add the plus sign, it's like in mathematics. If you add it to a number, a positive integer, or if you don't, doesn't really matter because it's going to be implied that it is there. But the negative sign, it's not going to be implied, so we are going to add it. Plus is going to make it optional. Negative is going to make it required. And these are the three types that we're going to cover in our upcoming lectures. That is it. And just one more thing, just to put everything in perspective, these are called mapping modifiers. Read-only, negative sign, question mark, and then the positive sign that we have right here. These four are mapping modifiers. You need to keep that in mind in case you hear it somewhere. Let's talk about the read-only mapped type. We have an interface of product with two properties, name and price. We've created an object, and we have also logged it. And why do we need the read-only map type? Well, consider an interface or a type that has 10 or 20 or 50 properties, and you want all of that to be read-only. Now, what you would do is you would have to add the read-only access modifier one by one to all of the properties. Now, that could be something that you would want to do, but there is actually another way. And the reason that you want it to be read-only is so when you create the object, you assign it a value, the property is a value, you assign the property a value, there shouldn't be any other way to change that. So in this case, if I access the product, if I get the name, I can successfully change the name from TS to JS. In the console, we have TS. If I save this, now in the console, I have JS. Now I can do this. But a read-only map type, what it does is it loops through our type, and for every key, it grabs that key and it makes it read-only. So we don't have to add this type to add read-only access modifier to all of our interface. We can just leave our interface as it is, and we can basically do the same thing with a record. Why do I keep saying record? With the read-only map type. So for that, what I'm going to do is we're going to do the same thing. I'm going to create the map type, and then we're going to take a look at the TypeScript implementation of that. Let's call it read-only with a capital O type. This is our naming convention, and it is very simple. We need to provide a reference to our type, and then we need to iterate through the keys of the type. how are we going to iterate through the keys? So first we need something that would iterate. In the scenario, it is the key. Like it's a loop variable, like I, for I, something. Key n, now we need to iterate through the keys of this type. And the keys of the type are given to us in a union context if we use the key of operator. What is the type? The type is the one that we have selected above. And every time we are iterating through them, we want to get their types. We want to get the types of the keys. For every property, we want to get the type of that property. In other words, we are indexing into that type. So it is safe to say that we're using an indexed access type. Now this is a normal one. It doesn't have any mapping modifier. So let's add that read-only access modifier. Now I'm going to get rid of this. I'm going to access the read-only type, and I'm going to pass in a reference to our type. Now this type in this scenario is our interface. We iterate through all the keys of that interface, and we get we assign them, or basically get their values, the type of their values right here. We basically index into that type, and we make everything read-only. All right, I feel like I should go over this one more time. We have an access to our type. Here it is, here it is, here it is. This is our type. We iterate through the keys, and every time, for example, when we get the name that has a type of string, how do we get that? We iterate through it, but how do we actually get that the type of this is a string? We get it through here, type, key. We are indexing into this type. And then whatever we return, whatever is returned from there, we are going to assign to it a read-only modifier. That is going to make it read-only. So in each iteration, we get one property and we make it read-only. We get the property type, and then we make it read-only. And then we move on to the next one and next one. Now, as soon as I do that, there is an error, cannot assign to name because it is a read-only property. It's that simple. And it is my obligation to show you the actual read-only as well. And you can take a look at that by just getting rid of this type and making this O smaller, lowercase. And there is still going to be that error. And control click, there we go. Here it is. I've just provided like more sensible and understandable names to the types. And with this, I'm going to comment this one out. With this, our lecture has come to an end. See you in the next one. Hi everyone. In this lesson, we're going to talk about the required mapped type. Well, what I have in front of me is sort of a dilemma. I don't know what to do. I have an online course object that I have type annotated to this product interface. And within the product interface, there are 4 properties, 3 of which are optional. Only one is required, which is name string. And then I have this other object, in-person workshop. I've type annotated to the same thing, and it requires just that name, because that is required. Now what I could do is I could just go about my day. I could add the price 10.99. I could add the rating 4.6. I could add sales, for example, this many sales. Just add a comma, and I could save that. But there is no way that TypeScript is going to tell me that I need to provide the price, I need to provide the rating, I need to provide the sales. Now, what I want to have is, for my online course, since I'm selling that, it should have a price. It must have a price. Since the students are rating it, it should have a rating. And since I'm having sales, I need to have a number for sales. But the in-person workshop is different. The name could be of that type string, but I don't have any price because that in-person workshop, perhaps I'm like arranging that for university students for free. I'm just doing that out of the kindness of my heart. And there is no rating. It's just like 1-day workshop or 2-day workshop. That is it. And there are no sales. So it doesn't make sense if I make all of these, if I just get rid of all the question marks, it is going to be required in the in-person workshop, which in my opinion, it doesn't make sense. I don't want to have price, rating, and sales. It is just one thing that I decided to do. But if I make them optional, then this online course is going to get hurt. And I don't want to have two interfaces that have the same properties. I don't want like repetitive code. So I have different criteria for the online course and different criteria for the in-person workshop. So how am I going to solve this while having that compilation error that is going to tell me that I'm missing some properties? So that is where the actual required map type comes into the picture. This is actually one of the examples. It's a very, very simple example, but I'm sure you can understand this. So what I'm going to do is I'm going to create this required map type. And wherever I use this required map type, what the required map type is going to do is it's going to grab all the properties of a type and it is going to make them required. And it doesn't matter if they have this question mark. They're going to be required. So I'm going to use required for this. And for this one, I'm just going to use this product. Very simple. We need to pass in a reference to a type. In this case, that is the interface type. And it is similar to the previous one, which was read-only. So we have key and key of, it iterates over all the keys of this specific type. And in each iteration, we do something with the type. First, let's index into that type using the key. What do we want to do? We want to make them required. Now, if I do a question mark, this is going to be optional. This is going to make everything optional. But if I add a negative sign in front of that, it is going to make everything required. So this is a required map type. The only thing I have to do is I have to type annotate this online course with that. And in here, I'm going to say required. And as soon as I save that, you can see there is an error. It says type name string is missing the following properties. What are those properties? Price, rating, and sales. Very cool. So now I have to add a price, and I know that I need to add that. So there is no way around it. And, and I need to add the rating. Come on, buddy, 4.6, and sales. And now I'm sure that both of my types, even though I'm using the same interface, I'm using it in two different ways. In this scenario, everything is required, even though they have this question mark. But in this scenario, all these are optional. Only the name is required. And for an in-person workshop, I'm just interested in the name. I am not interested in the sales. I'm not selling it, so it doesn't have a price. When I'm not selling it, it doesn't have a price, it doesn't have sales, and I'm not really interested in rating. This is just something that I do like once, perhaps per course, and it's just something that I do. I don't care about the rating. It's like an optional thing people can attend. I don't want to get too deep into the why I do it, but perhaps if I were faced with this kind of issue, a required map type would solve that. And this required map type, this is also built into TypeScript. We can take a look at that. The official required map type. Let's comment this one back and control click, and there we go. So we have this negative sign and the question mark. That is the only difference. I'm going to comment this one back and comment it out, comment this one and there we go. We're going to work with our own. So I hope you really understood what this required, where we can use that. And that is it for this lecture. In the next one, we're going to talk about the optional map type. Hi everyone, in this lesson, we're going to talk about the partial mapped type. The partial map types make any type optional. That is why it's called partial. It's like it makes it a part of the original type. Now, in this scenario, what we have is, in this lesson, we have all these 4 properties, and all 4 of them are required. There is no question mark, so that is the difference between this one and the previous lecture. And since all of them are required, that is what we want for our online course. We went over that idea. But that is not something that I want for my in-person workshop. So what am I going to do about that? I need to create a type, a mapped type, that would iterate over all the properties of this interface and make them optional for me. That's the only thing that I want to do. So I'm going to create a type, and I'm going to call this partial type, since that is the name, the actual name. We need to reference a type and then iterate through all the keys of that type. So key and key of that type. And then when we iterate through it, in each iteration, we need to access every individual key. And as soon as I do that, I need to make them optional. So plus question mark is going to make them every property optional. Now in this case, the name is still going to be required. The name is also going to become optional. So you need to keep that in mind. And now I need to type annotate this with that partial type. Let's save that, and there we go, the error is gone, and now we see the object right here. So it makes everything optional. There is another way that we can do this, and that is by leveraging the actual TypeScript partial map type. Here it is. If I take a look at it, there we go. Here is the plus sign right there. Now, since plus sign is inferred, we could add it, or we could just remove it, and it is still going to work. But you need to know that there is actually a plus sign, as opposed to our previous lecture, which was required. You can see that there is a negative sign. So when you see the negative sign, you should know that there is actually a positive sign as well for something that it does in reverse. And this is what we are going to do right here. And that is it. So we basically created a type, and that partial type is right here as well. That makes all the properties of an interface optional. And depending on your use case, you can use the partial map type, or you can use the required map type. That is it for this lecture. See you in the next one.
We use modules whenever we work with TypeScript projects or medium to large JavaScript projects. All of today's popular frameworks, such as Angular or Vue, or libraries such as React, depend on modules. A benefit of modules lies in their reusability of code. We can reuse the code from modules several times without repeating ourselves, which would adhere to the dry principle. And finally, modules allow us to write less bug-prone code and more backward-compatible code, since modules are evaluated in strict mode.
Hi everyone, in this lesson we are going to create a TypeScript project. Here I have VS Code open in an empty directory called modules, and there is nothing because we are going to get started from the ground up. The first thing that I would like to do is I would like to jump into terminal, so you can just bring it from here, new terminal, or let me close these two. We are just going to need one. You can just click new terminal, or you're going to do control backtick, and it is going to open up this command line for us. And in here, what I'm going to do is I'm going to initialize an npm project using the npm init. And there are going to be some things that we could provide, or we could just not provide, like the package name. I'm just going to set it as modules, as the default, which is modules, version, description. You can just write everything you want in here, but I'm just going to basically just move forward and not do anything. And what it did was it created this file for us. This is a package.json file where we can see the package name, we can see the version, description, and everything. These are everything that it asked us. So if I click on the package.json file, there we go. So this is like a very, very basic npm project. From this point onwards, what I would like to do is into this npm project, I'm going to install TypeScript as a dev dependency. What that means is that our TypeScript is going to be installed in this environment. It doesn't matter if we have TypeScript installed globally. I want to install it for this specific project. So let us do a clear. Now, if I were to say tsc --version, we can see that the global version of TypeScript is 4.8.4. But I want to install TypeScript in this directory, in this project. So I'm going to do npm install TypeScript. And then I'm going to give it a flag of save-dev, which is going to install it locally in our project. I'm going to hit enter. And it's going to take a couple of seconds. And we are going to wait for it. Let me just bring this down a little. And we are going to see the changes here. All right. It is taking a little bit longer than usual, which it shouldn't. All right, so it has installed TypeScript, there we go, as a dev dependency, which we needed for development purposes. And you can see from the time I started recording this course up until now, TypeScript version has changed. It was 4.8, now it is 4.9.4. It doesn't really matter, but that is what we have done so far. Now, since TypeScript is only used in development, TypeScript has to be compiled to JavaScript before going to the browser. For this reason, we need to create a TypeScript configuration file that is going to control how TypeScript is compiled to JS. So for that, I'm going to do tsc -init. This is going to create a TypeScript config file, and we are already familiar with this. We have taken a look at this like towards the start of this course. Now what I'm going to do is I am going to go over to my other VS Code that I have. I'm going to copy some settings, select all of these, delete them, and I'm going to paste these settings right here. These are the settings that we've been building up so far in our sections. So I basically pasted all of that. I'm going to save it and I'm going to close that file. What I'm going to do next is that I'm going to create our dest and source folders. So in here, now as soon as we install that TypeScript, we can see there is a node modules folder, and there is just one dev dependency, that is TypeScript, that we have installed that. So I'm going to close everything. I'm going to click in the directory, and I'm going to create a folder or another directory that is called source. I'm not going to create a dist. That is going to be handled by the config file for us. And within the source, what I'm going to do is I'm going to create a file. I'm going to say to creating -a-ts and then project.ts. And let's save that. And we can see that it is not actually being compiled into JavaScript. That is because we have not actually compiled our TypeScript. So what I'm going to do is I'm going to click on this plus sign in the right here, bottom right. This is going to create another editor, another terminal for me. And in here, I'm going to run the TypeScript server that is going to basically compile everything. So tsc-w. Let's save that. And now it has created a dist folder for us. Now, I'm going to keep this terminal open here, and I'm going to jump back into our first terminal. This is the first one. And if I take a look at the dist folder, we can see that here is our JavaScript file. In here, what I'm going to do is, first off, within the TypeScript file, I'm going to create a function, a very, very simple function, and I'm going to export it. So this is going to be a function declaration that is going to get the product name for us. Get a product name. Where is the G? There we go. Get product name. I'm going to pass in. So when we are getting the product name, we are going to pass in an object. And that object is going to have a property product name. And as we are passing it, I am going to destructure it at the same time. So product name. This is going to have this shape that I'm going to specify for it, a product name property that is going to have a type of string. And what this function is going to return is going to be a string. And let's just return product name from here. There we go. Everything is okay. I'm going to log this to the console as well. Get product name. And let's let's first provide the object, product name, and I'm going to call this TS Bootcamp. So everything is making sense so far. This is a very, very simple function. The reason that I want to dive into I gave you this function as an example is because I want to dive into how you can export this function. That is the main idea behind this section. We are talking about importing, exporting, and all the different techniques that are involved there. Now, the first thing that you need to understand when exporting any kind of functionality is that when we're talking about regular TypeScript, we can only export declarations. A declaration is any kind of variable declaration using let, const, or var. It also includes functions like this one. It also includes async functions and classes. They also fall into the category of declarations. Now, what I'm going to do is I am going to export this as a named export. And what that means is that we are exporting the name of this function. So right before the actual function keyword, I'm going to write export. Now, it is going to export this code for us wherever we want. So where is it being exported? Wherever we want to import it. That's where it is going to be exported. Now, what I'm going to do is I'm going to head back to our tsconfig file, and I'm going to try to keep these two open since we are going to go back and forth. And in here, there is a key of module with a value of common.js. Now, there is something that you need to be aware of, that common.js is actually a module format that the TS compiler will produce when it transpiles the code into JavaScript. Now, this is because of the setting called target, which by default is set to ES5. Now, I have copied these settings, these compiler options from the other window that I have open, but if we compile it, most often you're going to see that this target is set to ES5. That is why it is going to be common.js. But if I remember correctly, even before copying this, the setting, the target, was set to ES2016. There we go. Since that is what I've actually done before. So I'm going to come back here. Now, this is one module format. We have other module formats as well. We have AMD, we have UMD. The most common is this common.js. Now, this common.js basically says that what I'm going to do is I'm going to support these modules. Since modules are not supported in the ES5 version of JavaScript, we needed some sort of a module loader like common.js, AMD, or UMD to basically transpile modules for us and convert them into JavaScript. Now, what I'm going to do is I'm going to take a look at the compiled JavaScript. Keep in mind, we have this code right here, and we want to take a look at how this is going to look like in JavaScript when the module loader is common.js. So if I jump in here, we can see some stuff that we have not actually seen before. What we have is that we have this line right here. What it does is basically this is going to add a property of __ES modules on a global object that is called exports. This is a global object that is provided to us by the common.js with a value set to true. What this line says that before we have initialized the function, the return value is going to be undefined. Then we initialize the function. Then we again take a look at that function's value, what it is going to return. But keep in mind, they're all being appended to this global object right here. And then basically we log the value. So we could go ahead and we could change all of this to a more modern module syntax, all right? And what I'm going to do is I'm going to first talk about how we are going to be able to actually take a look at that in the browser. Now, for security reasons, we need to install a module dev server in order to see our modules in the browser. So I'm going to come back to the terminal, and in here I'm going to say npm install es modules hyphen or dash dev dash server. And I'm going to install it as a dev dependency, the same thing as with TypeScript. Let's hit enter, let's install this. And we're going to take a look at our dev dependencies right here, and we should be able to see them change. And there we go. So we have installed ES modules as a dev dependency right there. Now, what this is a very minimal development server that runs on Node.js. And before running the server, what I'm going to do is I'm going to just create an index.html file here. Let's provide some stuff. I'm going to say modules and spell it correctly. Very good. Let's jump into script. And I'm going to grab our script. It is within the dist folder and creating ATS project. Now, since this file creating ATS project.js, this is a module, we need to specifically specify the type as module if we want it to work as a module for us. Now, since we have created our index.html file and we have linked that to our JavaScript, I'm going to jump back into our tsconfig and I'm going to remove this, and I'm going to, instead of that, I'm going to provide ES 2015, which is also supported. And as soon as I do that, if I take a look at the code again, you can see we have the same thing in TypeScript as we have in the JavaScript, just the type annotations are compiled away. So we're strictly going to talk about modules in the context of this ES 2015, all right? Next up, let's launch our development server. And for that, I'm going to jump into our package.json. Here are the scripts that we can run using this package.json. I am going to change this test to serve, which makes a little bit more sense. And I'm going to change this message to the following. So I'm going to say node underscore modules. And from there, we're going to get ES modules underscore, dash dev dash server. All right, so everything is cool. Finally, let's go ahead and let's run our web server. So this is, again, ES modules dev server. This is going to create a very minimalistic server for us. And that is why I have this one terminal here and the other one that is basically compiling our TypeScript here, because we'll be running two kind of servers. One is going to be compilation. The other one is going to basically serve our web page. And in here, I'm going to say npm run. And when I do run, what is the command? What is the script that I want to run? It is called serve. So I'm just going to write serve here. And as soon as I do that, this is going to basically open up this web page in a local host and then open up the default browser automatically. Now let's jump into inspect, console, and there we go. I'm just going to reload the page. Here is our message. That is it for this lecture. See you in the next one. Hi everyone. In this lesson, we are going to talk about importing code from a module. So this is where we left off in our previous lecture. And what I would like to tell you before moving forward is that what I actually decided right now on the spot is that I'm not going to create more lessons. Let me just bring this down a little so we can have more space. I'm not going to create like lesson 3, lesson 4, since these are like really very, very simple lessons. I'm going to be creating all of them within this one lesson, and I'm going to be commenting out the previous iterations. We are mainly going to work with some general concepts, and it's not like you have come so far and it's going to be very easy for you to actually recreate everything just by watching the videos. So the actual source code that we have this function right here, what kind of function we have, what kind of function it is being compiled. Doesn't really matter. What we are actually focusing on is that these kind of export and import syntaxes. So I'm going to change this the name of this file to creating a TS project to TS-modules. And I'm going to save that. This is going to create another file for me. I'm going to get rid of that. Let's jump into our index.html. And this is going to be TS. And it is going to be easier for you to follow along as well. And if I take a look at the browser, if I just refresh the page, now keep in mind, since our server is not being served with the live server, every time that we want to take a look at our changes, we need to reload this. And there we go. Everything is there. So far, everything is cool. So what I want to do in this lecture is actually import this code. Now, we talked about how this is a named export because what we are actually doing is we are exporting the name. There is another way of exporting, and we're going to talk about that briefly. So first off, what I'm going to do is, you know what, before importing, let's take a look at that another syntax. So I'm going to copy this, and then I'm going to comment it out. Let's provide a line break there, and then I'm going to paste it right here. So instead of exporting the function right here, I'm going to get rid of this export keyword. I'm going to define the function, and then I'm going to come down here. And in here, what I'm going to do is I'm going to open up an object or pair of curly braces, and then I'm going to reference the function. This is going to export the function for us. And I'm going to get rid of this console log as well. Let's just get rid of it. And let's bring it after the export. There is no actual meaning behind bringing it after the export, but this is what I like to do. Now, this is actually called an export statement. One of the advantages with an export statement is that you can export more than one thing. And the only thing that you need to repeat is like this. You are going to provide everything within this pair of curly braces. But if you are going to go this way using export names, then you need to provide that export keyword in front of everything. We are going to explore these, don't worry. I'm just warming you up to these ideas. And all right, next up, what I would like to do is I would like to show you that you can also change the name of this function as you are exporting it. So this is going to export the name of the function. I'm going to comment this one out, copy it down below. For example, this function name is really large, really long. You don't want to export it as get product name. Maybe you want to export it as product name. Maybe you want to export it like this, maybe like with a capital P, something like that. So you can do it like this as well. And you might be thinking, okay, how can we export multiple things together? Now I'm going to show that to you as well. I'm going to bring this export down, and I'm going to comment this one back in. And before the export, I'm going to create an object. Very simple, no shape. It doesn't have a shape. It just has a name property of TS and a price property of 10.99. Since we are not using the object, there is that yellow squiggly. Let's use the object. So we are going to separate them, your export statements, using a comma. And then I'm going to provide the course. And there we go. That error is gone. Now, let's go ahead and let's import these. Now, where are we going to import these? These are TypeScript modules. We want to export them from a TypeScript file, and we want to also import them into another TypeScript file. So let's create that. This one I'm going to call import, or basically ts-import.ts. The TS is going to be the same. So I want to import everything right here. How am I going to import that? The way that we're going to import that, the first thing that we're going to do is we're going to write literally the word import, and then what it is that we have actually exported. Now, if you want to import something, you need to take a look at what you have exported. So we have exported get product name and course. Since these are export statements, we need to import the same thing. So just to show you how these work, I'm going to get this object, copy it, put it right here. So far everything is working correctly, but there is something else that we need to provide. We have exported a function and an object, and we have imported them here as well. But where have we imported them from? We need to provide a path. So I'm going to say from curly braces dot / which is going to refer to the current directory. You need to provide this. And then what is left? You're going to have TS modules, and then you're going to have TS imports. So we have imported them from TS modules. And there we go. Now there is just a squiggly. That is because we have not actually used anything. We can use them, and you can take a look at their values in the browser as well. I'm going to call the get product name. Now keep in mind, when you're importing these declarations, they become local to this file, to this module. So you can use them in any way that you want. Even though we declared the function right here, we're importing it right here, and then we are going to call it here. I am going to copy this line. I'm going to comment that one out there. Let's put it right here. There we go. That is the log of the function. Let's log the actual object as well, which is going to be course. And if I do a dot notation, what do we have? We have a name and we have a price. And this is very cool. We are in a different file. We're in the TS imports, and we have imported them from this TS modules. And this is very cool. So I'm going to go back. I'm going to save these. Let's jump here again. We need to refresh this. We don't see anything. And let's take a look at our index.js, TS modules. That is because we need to actually load this TS import. So TS import, let's save that. Let's come here, reload the page, and there we go. So we got this product name that the function spits out, and then we have this object, name TS, and the price is $10.99. So everything is working correctly so far, right? And the same with having an alias for what we can export. We can have an alias for what we want to import. So I'm going to comment this line out, copy it down below so you can have it as a reference. We can alias this name, any of these names that we want. For example, again, this product name is extremely large. You just want to say product. So I'm going to say as product. And as soon as I do that, this is going to throw an error because now this name doesn't exist in the scope of this file. So you need to change that here as well. Product. Perhaps lowercase p would be better. And now if I save it, jump into our server and take a look at the result, everything is working perfectly fine. And I think that is going to be it for this lecture. See you in the next one. Hi everyone. In this lesson, we are going to talk about how to re-export and export. Now, what I'm going to do is I'm going to create another file, and I'm going to basically call it re-export.ts. The job of this file is to re-export this code. So here we have a function, right? And what I'm going to do is I'm not going to overcomplicate it. I'm just going to grab this course, put it right here, comment it back in. So you can see all these lessons are being separated by this line. If you want to know which lesson ends and where the other one starts, besides watching the videos. Now, taking a look at that, what I'm going to do is let us go ahead and let's export this, export it. And I have this within my TS modules file. I'm going to jump into here, and I can re-export this one without importing it. Right? That is really cool, right? So what I'm going to do here is I'm going to say export course from where? We need to provide an address for it or a path for it. That is from TS modules. And as soon as I do that, there we go. We just re-exported that. Now, the thing with re-exports is that this object is not accessible within the scope of this re-export.ts. So if I were to do like whatever, If I just do course dot, it's not going to work because it is not a local variable. It's not a local object. We're just re-exporting them, which means we are not actually putting them in the scope. Let's jump into our import, and now we can import it right here. How are we going to import that? We're going to say import course from, now where did we re-exported it from? From the re-export. So let's provide the address for it from there, and there we go. And it basically says that we need to read it. We could take a look at that in the console of the browser, save that, jump here, reload the page, and there we go. There is our object. That is it for this lesson. See you in the next one. Hi everyone. In this lesson, we are going to talk about exporting and importing code from barrel files. I will explain barrel files in just a moment. First, I need to show you what they are. So let's jump into our source directory. I'm going to right click. I'm going to create a folder here, and I'm going to call it utils. So far, everything is cool, right? And within this utils file, utils directory, I am going to create 2 more files right here. Well, actually 3, but first I'm going to create 2 so I can provide a reason why we would need the third one. The first one that I'm going to create is going to be array.ts, which is going to contain basically like a very, very simple array. Very simple, all right. And this array is going to be called const products list, and I'm just going to provide the items as ts, js, and then Python. Cool, and I'm going to export this. Let's export it. Export. Very cool. Where is the, I didn't create the object. Let's create the object.ts. And within the object.ts, we are going to have one object, which we're going to export. So I export const product. This is going to be one singular product. That is going to have a name of Python Bootcamp. And the price for this one is going to be $11.99. So far, everything is making sense, right? So we have one array, we have one object. Now, what we're going to do is we're going to talk about barrel files. Barrel files simplify the process of imports. Now, what if I want to export this object, this array, using like just one file? So I want to have one file within this utils directory that can re-export everything from the utils directory. That makes managing our modules a lot easier. And that file, as a standard convention, is called index.ts. And that is why we are going to create that index.ts. Now, the index.ts, now these files, they're called barrel files because they simplify the process of imports. The only thing that you need to keep in mind is going to be circular dependencies. When one file's import depends on the other file's export. That is the only thing that you need to keep in mind. So what I'm going to do is I'm going to use something that is called a wildcard, or the asterisk, that is going to grab everything from the object module and export it. And then we are going to get everything that we are exporting, of course, from the array module and export that as well. So it is very easy. Maybe we have like 10 files and we are re-exporting everything from this barrel file, and it is easier for us to keep track of what we have exported and what we have not exported. I'm going to close these objects. Now what I'm going to do is I'm going to go ahead and I'm going to actually import these. Where did we import? Right here. So how are we going to import these? That's going to be very, very simple. Just copy that, put it right here. I'm going to remove the space. There we go. Here is our lesson. Now, what did we export? We can import that. You need to keep that in mind. So we exported a product, and we can see the actual pop-up there as well. And we also exported a products list. There we go. Where We exported them from the utils directory. Now keep in mind, I'm not providing any kind of module. Utils is a directory, it is not a module. So that is the cool thing about these barrel files. We don't need to reference the index. That is why index.ts is a common convention, because when we just reference the actual directory for that barrel file, it is going to be just that module or that barrel file is going to be considered automatically, so we don't need to provide it here. There are like two things that we need to pay attention. There is like a yellow squiggly and there is like a red error. I'm going to hover on the error and you can see, let's take a look at this, what it is being said. The yellow squiggly says all imports and import declaration are unused. All right. The error says cannot find module utils. Did you mean to set module resolution option to node or add aliases to the paths object? Now what I'm going to do is I'm going to jump into the TS config file, and in here we're going to provide a module resolution. Now here it is showing us that it is classic. Now in 99.9% of the times you want the module resolution strategy to be node. Classic is used for mostly backward compatible code. So that's why we just use node, which is going to be like the main thing that you're going to be using. Module resolution is what we are going to talk about towards the end of this section. And it basically refers to how TypeScript locates and loads modules. And then these two processes, they're called resolution. How a module is resolved. If the module is found, if the module's code can be loaded, it means the module is resolved. There are no errors. If it is not located or the code cannot be found, then it is going to be, we are going to end up with an error that is going to say module is not resolved. I'm going to show you an example of that, but first we need to talk about other stuff. That is going to be a little bit of advanced topic. That's why we are going to cover that towards the end of this section. Now, as soon as I save this module resolution to node, which is something that we want, we can see from TS imports, we just have one yellow warning. We don't have that error. So the error is gone. The warning basically says that we need to use these. And I could say product and products list. Let's save both of these. Let's reload the web page. Hopefully we can see our changes, the array and the object, and we don't see them. Let's see what is happening here. So here is our import, and we have exported everything correctly. Let's take a look at what we have here, and there is an error there. And how can I take a look at the error? Let me just rerun the server again, and there we go. So it says ts modules.ts is not a module. And where is this error coming from? Export course from ts modules. It looks like that re-export that we have done. So if I come into the re-export, there we go. Since we changed that module resolution setting, that's why it is throwing this error. So I'm going to comment that one back, comment it out, close this file, come into the browser, reload the web page. There we go. We got our object and we got our array. Hi everyone, in this lesson we are going to talk about default exports and imports. A default export is used when we want to export a single declaration or expression. From our knowledge of named exports, we know that we can only export a declaration. However, a default export can also export an expression like 1+1. Another feature of default exports is that we can only have one default export per module. The syntax for a default export is also different. How is the aim of this lesson? First off, I'm going to create a course object, const course, and it is going to be the same thing as we've been working with. Oh, right, that is an issue. We shouldn't be working the imports, so let's jump into the modules. So I'm going to get this course object from there. I'm going to uncomment this one. And here is our lesson. Now, how can we export this by default or default export it? We're going to say export, and then we're going to write the literal word default and then the object. This is a default export. Now, this export, this is not an expression. This is a declaration. This is an object declaration. But we can export an expression like a string, like a very simple string, not a variable declaration, but the assignment part of it. So we're going to say export default, and then I can just export Python bootcamp. Let's save that. If I hover on this, it is going to say a module cannot have multiple default exports. The first export default is here. It's right here. So we can have multiple of these, but we can actually export anything that we want. But when it comes to named exports, we cannot export an expression like export, and then I just do like 1 + 1. This is not going to work because declaration or statement expected. But we can do 1 + 1 with a default export. Now, with a default export, we cannot export a declaration directly. What do I mean by that? So if I comment this part out and copy it, put it down below, and if I try to export this directly using default, this is not going to work. If I hover on it, you can see it says expression expected, and then it's going to say that this is not being used. So what I need to do is I need to get rid of this const, and then there's going to be another thing, cannot find named course. So I need to get rid of this one as well, and then there's going to be like expression expected. And then I need to get rid of this equality sign as well, and now this is going to work. And we're basically exporting this object. So when it comes to this, we can export a declaration if we do it like this, but if we wanted to have that export default on the declaration, it can't work like that. We need to have an expression in there. And for your relief, I'm going to export 1 + 1 as well. 1 + 1. And since like there are two default exports, I'm going to comment this one in. We are going to jump into our imports, and we're going to see how we can actually import these defaults. I hope you're not getting confused. These are like very, very simple stuff. So first off, let's see how we can import an object. I'm going to comment this one out, comment these parts, and these are like different exports. We are going to now talk about different imports. I'm going to say import default course from, we'll need to provide the path, and there we go. That is it. We can take a look at it in the console. Let's save that. Let's jump here to the browser, reload the page. There we go. Here is our object. Everything is cool. So this is exporting an object. How can we export a string? But before actually jumping into talking about exporting a string, there is a cool thing about these default exports. When we export a named export, the thing that we export has to have the same name as the thing that we exported. But that doesn't really that is not the case with a default. So in here, I can say default course. I can say course object. Just copy that line, put it right here, and then course object, save this, reload the browser, we're going to get the same result. So it doesn't have to be the same name. In here, what did we export? We exported this course. And in here, we said default course, which doesn't really exist here. And then we said course object, which doesn't really exist here. So we don't have to abide by that naming convention. Now, this is one flexibility. The other flexibility is that we can export a string like this one. So I'm going to comment this entire thing out. I'm going to comment this one in. So since we can have only one default export per module. And I'm going to copy that, copy this one as well, and then I'm going to rename this to something that makes sense. So default string Python, whatever. And now let's comment this one in, reload the page, Python Bootcamp. Everything is making sense, right? It's very simple. And finally, how can we import this 1+1? Well, we do it in the same way. It's very simple. So I'm going to save that. If I come here, I can basically say default string Python. That would work. Or I could just copy it down below, comment these ones out. And I'm going to say add one. I'm going to say add 1 to 1. Something like that. Very, very silly, but it proves my point. It works. Save that, reload the page, we got 2. So that is everything you needed to know about default exports and imports, or default exports and imports. See you in the next video. Hi everyone. In this lesson, we are going to talk about the export assignment and the require function or method. There is actually another syntax for exporting and importing that you need to be familiar with. It is called the export assignment syntax, and it doesn't work with the ES 2015 module syntax, module format. So we need to hop over to tsconfig, and we need to change this to either CommonJS, AMD, or UMD, then it is going to work. So I'm just going to change it to AMD, then it's going to work. Otherwise, it's not going to work. What I'm going to do is I need to tell you like a couple of more things about the export assignment. The export assignment, when you want to use it, there are like a couple of limitations. The first one is that when we have an export assignment in a module, we can't have any other export. But when we talked about named exports, we could have like several named exports. We could have like one default export with several named exports. There is not going to be any kind of issue. For example, we could export a variable product that has a type of string that is TS, and then we could export default.ts string, and then it is going to be okay. But when we talk about the export assignment, that can be the only export in that file, in that module. You can have multiple exports with an export assignment. And that is the first limitation. The second one is that export assignments, they cannot be re-exported. So you need to keep that in mind as well. Now, how can we use export assignment? Well, it is the same. It is as the name suggests. We need to use export assignment. So I'm going to say export assignment, and then let's say I want to export this word cool. This is an export assignment. In order to import this, we need to use the require method. So I'm going to say import cool from where? Now this require method, this is available globally, require, and the only argument that it accepts is going to be the path where we have actually exported something. So that path is going to be TS modules. And now, well, I could log this. I could try to log this, but this is not going to work. Why? Because CommonJS modules, let's take a look at this. Let me just save this. CommonJS modules, they cannot be shown in the browser. We would need to have like a third-party module loader like Webpack or Babel that is going to be able, that will help us to actually view this content in the browser. We could try, but that is not going to work. So if I reload the page, you can see it says defined is not defined at this, because CommonJS and browser do not mix. You need to have some other kind of tool that would help us to actually load this to the browser. But we can see that the import works perfectly fine. I'm going to get rid of this log, and I'm going to comment this one out. Since now you know how these export assignments work, that is going to be it. Let's jump back into tsconfig, and I'm going to change this to ES 2015. Back to ES 2015. That is it for this lesson. See you in the next one. Hi everyone, in this lesson we're going to talk about how to conditionally load code from a module. The import statement and the named imports that we have been talking about, they cannot be nested in a conditional. And they have to be the first lines of code in a module. But there is actually another syntax that is called the import expression, which is supported in the CommonJS module format or the ESNext module format. So for that for this import expression, we cannot use ES 2015. I'm going to do ESNext, which is a placeholder for the next generation of JavaScript additions and updates that have not become a part of the actual ECMAScript specification. Wow. And I could say CommonJS, but then CommonJS cannot be loaded into the browser directly. I'm just going to do this next so we can see our result. And the aim of this lecture is that we want to load some code conditionally, import them conditionally. And what is going to be that? So I'm going to say export. Let's create a variable called released. Now, if I'm going to create two variables and I'm going to export them. And one variable is going to be a Boolean that is going to say true. And the other one is going to be a variable called course name that is going to represent the name of the course. Now, if the course is released, I want to show the name of the course in the log of the browser. Otherwise, I don't want to show anything. So there's a condition. Let's save this. Let's jump here. First off, we need to import these. Import using regular import statements. I'm going to grab the released, and then I'm going to grab the course name. Now that I've imported them, I can conditionally load the code from them. Now, you need to keep in mind that this import expression, which is like this, it accepts a path, and then it gives us a promise. That promise requires a handler to basically handle what the promise has returned, whether resolve or reject. And that handler, as a standard, is .then. So we are going to use a .then method. Now, what do I want to do here? I basically want to show the name of the course conditionally to the log of the browser. So I'm going to say the course name is course name. Now, if the course is released, we will be able to see this course name. Otherwise, we won't. The course name is TS Bootcamp. There we go. That is cool. Let us change it to false. Save this. Come here. Reload the page. There we go. There is nothing being shown. So that is it for conditionally loading code from a module. See you in the next one. Hi everyone. In this lesson, I'm going to show you how to import JSON files. Firstly, let's create a JSON file. I'm going to jump into the source. I'm going to say new file. Let's call it config.json. Let's open this up, create a JSON, a very, very, very simple JSON object. And this is going to be user name. And I'm going to give it a value of EL. Very simple JSON object right there. Cool. How can we actually export that? How can we import it into our file? Since we are directly importing it, we are not going to do anything here. Let's just jump into TS imports. And it is very simple how we can import this. We're going to import wildcard selector, select everything, as config from the file. So where is the file? The file is going to be config.json. Let's save that. Now, there is an error there, and we do expect that error. So if I take a look at that, we need to resolve this JSON. Currently, there is no setting, there is no flag to resolve JSON modules. The reason that we need this is because these are not like regular JavaScript modules. These are JSON or JSON modules. So I need to jump into the tsconfig file. And in here, I'm going to say resolve JSON module, set it to true, provide a comma right there, save that. And if I come back here, we can see it is working. Now, there is actually another thing with this loading JSON files as well. For the same reason that they're not JavaScript, we cannot load them directly to the browser. And we need to have like a third-party module loader such as Webpack to do this for us. But currently we just have that yellow squiggly, which means the value is never read, which means that there is no error. And I'm going to comment this one out. That is it for this lecture. See you in the next one. Hi everyone, in this lesson we are going to talk about ambient modules. An ambient module is a feature of TypeScript that allows us to import libraries from JavaScript as if they were written in TypeScript and use them safely. Ambient modules are created using the ambient declaration file that describes the module's type, but it doesn't contain any kind of implementation. Now, to work with ambient modules, we need to simulate like we are working with a JavaScript library. For that, I'm just going to create one very simple JavaScript file, and I'm going to call it ambient.js, which is just going to export a simple function for us. This function is called addition that accepts two parameters, and it returns a plus b. Remember, JavaScript, no type annotation. I'm going to keep it right here. Now, to be able to work with JavaScript within TypeScript, we need to allow it. So I'm going to say allow JS, set it to true. And I'm going to turn off the declaration setting as well. Declaration, and I'm going to set it to false since we don't need it currently. All right, let's jump into this file. Now, how are we going to import this? So we're not going to work in the TS modules. We're going to jump into the TS imports. First off, what I'm going to do is I'm just going to use an import statement. I'm going to say addition. I want to grab the addition from this file, .ambient. Save that, and we can see there is basically a squiggly that says that we have not actually read the value. Now, it has been imported, and we can see that, but if I take a look at the addition function, what do you think we are going to see? If I hover on it, we can see that the addition function, there is one parameter with the type of any, another parameter type of any, and the function returns, the return type is any as well. And from our current knowledge of TypeScript, we know that any is way more flexible than what we want. So how can we actually fix this? How can we provide a signature for this function that would correctly type annotate the function as we are importing it into TypeScript? This is one of the major skills and basically issues that you're going to face, and you need to basically develop this skill, how you can create declaration files. Now, declaration files are also, they can also be created using the tsconfig file as well. And I'm going to show to you how they are actually created. But first, you need to be able to know how you can create them manually. But typically in a larger application, you won't have to like create them manually, especially if you're consuming some kind of library. You need to let TypeScript handle that, which is actually good. So what we are going to do is, first off, I'm going to save that. And keep in mind, one more time, an ambient module does not contain the implementation. It just gives us enough information for type safety, just to make sure that we have our type safety. And ambient modules are also called declaration files. Let's jump into the source. I'm going to create a new file. The ambient module has to have the same name as the JavaScript file. So ambient, but the extension is going to be different. Since this is a declaration file, I'm going to do .d, and since we're talking about TypeScript, I'm going to do .ts. I'm going to open that. You can see that the logo is different as well. And now here, now these two are linked. I need to provide the signature. So I'm going to say declare, since this is a declaration file, declare this module. What is going to be the name of the module? The name of the module is going to be ambient. Keep that in mind. That is the name of the module. What is the module going to export? The module is going to export a function called addition that accepts one parameter A with a type of number. I want it to be of type number, and another parameter of B with a type of number, and its return type is a number as well. And I'm going to save that. And we need to get back to our importing. Let's take a look at that here. Now, as soon as I do that, if I come here, you can see it says that it is basically saying that this is not a module. All right. Now, what I'm going to do is the way that we can remove this error is just to remove it, remove the path from here. So I'm going to comment this one out, comment it back in, remove this, and now remove the /, and there we go. The error is gone. So now if I hover on the addition, there we go. We can see that A is a number, B is a number, and the function returns a number. Now, what was the issue with this one? We could have easily passed in a string, and that string could have easily broken our application. And that is not what we want. That is why we use TypeScript, just to make sure everything is type safe. When we pass in as far as, let me just comment this one out. Take a look at this. We still have that issue. If I just delete this, we can just bring it back as well. There we go. Now, if I pass in a string here, hey, and then we could pass in another string, hi, there is no problem. But we know that is not what we want. This is an addition function, right? So that is why we need to basically we need to create an ambient file, an ambient module, or a declaration file that provides the signature for the function, what the function is going to do. Now we can say like 20 plus 10, and it is going to work perfectly fine. Now, as I told you before, there is actually another way of creating an ambient module, and that is by letting TypeScript config file create it for us. But before actually showing you that, I need to tell you that since we are working with these kind of ambient files, they're not going to work in the browser, and we are going to have to need a third-party module bundler like Webpack to make it work. Right? Now let's see how we are going to make sure that TypeScript produces these ambient files for us. And for that, I'm going to come into the TypeScript config JSON file, and in here I'm going to set this one to true, this declaration, and I'm going to comment this allow.js file out. And as soon as I do that, if we take a look at this dist folder, there we go. What do we have? We have reexport.d.ts, tsimport.d.ts, and where are they generated? They're not generated in the source folder. Source folder is not something that we're going to commit to production. We're going to commit to production this dist folder, since this is not going to be read by the browser. And it is actually a very, very good idea to have our JavaScript files have a declaration file, so when other people consume our code or consume the library that we have created or the application that we have created, they will have perfect idea of what it is that we have done and what we mean by the variable A and, for example, and the variable B. So we have all of the files right here. I'm going to comment this one back out. And since we are not going to work with it, we have our function right here. We have the ambient right here. Let's just close those, and I'm going to comment these one back out as well. Comment them out. That is it for this lecture. See you in the next one. Hi, everyone. In this lesson, I'm going to talk about augmenting ambient modules. We created a declaration file for the addition function in the previous lecture. And we have already seen examples of augmentations when we talked about interfaces. Here, the idea is the same. We enhance our declaration file or augment it so it can work with a wider range of possibilities. And I want to make everything very, very simple so you can really understand the idea. Explicitly, we want to work with the addition function so it can have the ability of not accepting any kind of parameters. So far, we know that our addition function can accept 2 parameters, but what if I want to call it and not pass in any parameters? Just for the sake of argument, for the sake of understanding. And then what we need to do is we need to define an overload for the function. There are 2 places where we can define an overload. One is within our ambient module, which is not a best practice, since you're working with a library, JS library, and you want this to be generated by tsconfig file, you don't want to touch this manually. Just leave it as it is, and then we're going to jump into our TS import, and we're going to talk about that right here. And in here, I'm going to show you how you can augment your declaration file. So what I'm going to do is, first off, I need to import them. Let's go ahead and let's import these. Let's save that. There we go. We have imported them, and we can see that A is a number, B is a number. Let's allow JS as well. Very cool. Where are we? We are right here. We are in the import. Now, I'm going to say declare module. The syntax is the same. I'm going to call it ambient, since that is the name. And what do we want the augmentation to be? What do we want to augment on it? How do we want to enhance the capabilities? I want this function, which is called addition, to be able to accept no parameters and return a string. If I take a look at the addition function, we can see now there is an overload. What does that mean? It means if I call this function and not pass in any kind of parameter, any kind of arguments, it is still going to load. And now let's take a look at that. Now this function call, this is going to return a string for us. And it is going to show us that there is actually one overload. We can handle the string here as well. That augmentation possibility here, we're going to say if there is no A, or, come on, it shouldn't be uppercase, or there is no B, just return, please specify 2 numbers, or provide 2 numbers. You could handle it like this, which doesn't really make sense, but you could do that. So in here, the function returns a string. If I hover on it here, it returns a number. And I think that is going to be it. Again, we are not going to be able to see the result in the browser without the intervention of a third-party module loader, such as Webpack. See you in the next lecture. Hi everyone. In this lesson, I'm going to talk about module resolution and module tracing. There are actually 2 ways in which TS locates and loads modules, and these are actually called module resolution strategies. The first way is classic, and we actually talked about very briefly towards the start of this section. And the second way that we are going to work with is going to be node. Module resolution is going to be node. Classic is mainly used for backward compatibility. This module resolution, this node module resolution, is similar to how Node.js, JavaScript runtime, resolves modules. However, there are certain differences. These differences only arise if the module is not found by the TypeScript. So if TypeScript doesn't find the modules, it is going to look into declaration files, any TypeScript and JavaScript files. It is going to use the TS. It is going to use the types property in the TS config file, or it could look into the node modules folder, specifically the add types directory. Now, the Node.js modules are loaded using the require method, which we have talked about before. Now this lecture, we are just going to go over how TypeScript traces the modules. So for that reason, what I'm going to do is I'm going to get rid of our first terminal, and I'm going to get rid of our second one. I'm going to create a new terminal, a new clean terminal, and I'm going to bring it up since we are going to work in it. And I'm going to show you an example of how this module resolution is going to work. And to be able to actually see how the module resolution works, we need to turn on a flag. We could turn on that flag in the tsconfig file, or we could just provide it within our terminal or command line. Since we are not working in a production environment and we're just learning, this is like a very simple playground, you can think of it like that. I'm gonna add it to our terminal, but in case you're wondering what that is, if you want to add it to the config file of your TS or TypeScript, you're gonna say trace resolution and you're gonna set it to true. I'm gonna comment it out and I'm gonna keep it there. So what I'm gonna do is, keep in mind, we are within this main directory. We are not within the source. We are not within the dest. We are within this modules directory. So that is something that you need to keep in mind. So first off, let's go ahead and let's try TSC. And then I'm going to do -- trace resolution. And before actually doing that, let's just hit enter and let's see what is going to happen for us. Now, what are these modules that TypeScript tried to locate? Keep in mind, two parts, locating the modules and loading the modules. If we take a look at that, I could zoom it in a little bit so you can really see. The first one that TypeScript located for us was, tried to resolve, was the object module that we imported into the index. And what was the method? What was the module resolution? It was Node.js right there. And then it actually looked for that object. It found it, and that was the module resolution result. And then it prints module name object was successfully resolved to object.ts. So to be able to resolve this module, it has to find where that module is located. And it did the same thing for the array. Now, so far, everything is working perfectly fine. What I'm going to do is I'm going to try to enable some modules. And first off, let me just get rid of this. What I'm going to do is, what do we have here from our previous lessons? I'm going to comment this part back in, save it. And did we export this? I don't think we exported that. We exported this one. Export these two right here and up until here. And I'm going to come, whoops. Okay, let me go back up. I'm going to comment this one in, and I'm sure you know which lessons they are. Comment that one in. There is no error here. Let's import these here as product. Let me comment one out. There we go. Everything is fine. Let's jump into our directory, terminal. So we can see down below here we have our array and then we have our object, but towards the top we can see we have our TS modules. We didn't have this before. What is the resolution kind? It is Node.js. We can see it right here. And then it is trying to recursively find that. And when it finds it, it is going to say that module name TS modules was successfully resolved. All right, that is cool. Let me comment this part out. Comment these ones out as well. Let's take a look at our utils. How are we going to work with these? So this, we actually we have seen that. Let's take a look at our ambient files. How are we going to work with them? So we do have our ambient files right here, and we work with them towards the end of this file. And let me just comment these ones back. And I'm trying to show you something in case you're wondering what I'm doing here. Let us call this one more time. module resolution, and there we go. So it is saying resolving module ambient. What is the module resolution technique? It is Node.js. And let's see what it is actually saying. So it is saying that this module was not found in the Node.js module, node_modules folder. It couldn't find any ambient.ts. It couldn't find any ambient.tsx. It couldn't find any ambient.d.tsx, even though we have that, right? And then it tried to look everywhere. It couldn't find any ambient.js, .jsx. And then when it can't find that module, what is it returning? It is returning module name ambient was not resolved. Even though we know that that module exists, that module is right here. Here it is, ambient.d.tsx. This is the module. These two are the modules that we want to resolve. But TypeScript cannot find them. Now, this is where another setting comes into the picture. And in here, we need to specifically tell TypeScript through the types settings, which is going to be an array. We need to provide it the specific path for that ambient module so TypeScript can handle that, can actually resolve that module for us. All right. Now, these techniques are really important when you're working with larger projects. You have a lot of modules. And if any module cannot be resolved, you need to be able to actually work with that. All right. And these are extremely important also when you're working with third-party libraries and you're working with their modules. So when I'm looking at this, I need to provide the path to this ambient module. And where am I located? I'm located in the tsconfig file, and this path, this ambient module is within the source directory. So first I need to reference that source directory and then provide the name of the module, which is ambient. Now that I've provided the name, let's clear everything. Let's run this one more time. And if I take a look at here towards the bottom, what is it saying? Even though in here it says the module was not resolved towards the top, but towards the bottom it says type reference directive which is this ambient, was successfully resolved. All right, so this is how you can resolve modules. If there are any kind of issues, you are just going to provide the path within your config.json file, within your tsconfig file, and TypeScript will be able to resolve them without any kind of issues. And I think that is it for this lecture. See you in the next one.
When it comes to writing production-grade TypeScript applications, you have to compile your TypeScript using some sort of a third-party bundler. That is why in this section we're going to talk about Webpack, which is one of the most important and significant bundlers for JavaScript as well as TypeScript. What Webpack is going to do for us is it's going to grab all of our TypeScript files and it's going to cram all of them into one JavaScript file that will make it easy to understand, easy to read, and easy to load into the browsers. In this section, we are going to get started with creating an NPM project, and then we're going to take a look at Webpack, how it allows us to do something called a single file compilation.
In this lesson, I'm going to show you how you can watch for TypeScript file changes through NPM. First of all, we are going to go ahead and we are going to install a project through NPM. So I'm going to say npm init. And since I don't want the NPM asking me all of those questions, I'm just going to provide a -y, just yes for all the questions. And as soon as I do that, there is going to be a package.json file, which is going to be empty, which is empty currently. Just going to zoom out a little so we can see everything. And from this point onwards, let's install TypeScript locally in this directory. Save dev. Let's hit enter, and I'm going to wait for a few seconds until TypeScript is installed. There we go, 4.9.4. After that, I'm going to initialize a TypeScript configuration file. And let's jump into the configuration file. And we can see we have everything that we've been Most of what we have been talking about, I'm going to delete all of that, and I'm going to bring in what we have from our previous lecture. Let me just copy that, put it right here. Let's save that. This is, from the previous section. All right, we are familiar with all of them. I've talked about all of them. Now, what I'm going to do is I'm going to add another setting in here, another property rather, that is going to check for file changes. And we're going to basically tell TypeScript through this configuration which directories to exclude when checking for file changes. So keep in mind you need to be outside of the compiler option. So we have this compiler option, and then there is another setting. I'm just going to provide a comma, and that is going to be watch options. And in there, I'm going to provide in an array. It's going to be an array of directories, but we need to tell it which directories to exclude. So I'm going to say exclude directories. This is an array. And this array is going to contain, the first thing that it is going to contain is this node modules folder and all of its subdirectories. We don't want to watch this for changes. Therefore, I'm just going to provide here **node_modules. This *** basically looks through all of these subdirectories for us. I want to exclude this, and I also want to exclude our dist folder, the one that we are going to create. All right, so let's save that. Everything is okay. Since we are excluding the node modules folder and the dist folder, the only folder that we're going to be left with is the source folder. Therefore, from the root dir property right here, I'm going to comment that one out since we're not going to need it anymore. I'm going to create a new file here, and I'm going to call it index.ts. And let's just do one test. Let product type string be equal to ts. I'm just going to save that. Now, currently, we're not watching for anything. And I told you that I'm going to show you how you can do that through npm. So I'm going to jump into the package.json file, and this test, I'm going to change it to something that is meaningful, like watch. And then what was the command that we've been talking about to check for file changes? That was tsc-w. I'm going to save that, and now let's make sure it is working properly. So I'm going to say npm run, and then what is the name of the command? Watch. Let's hit enter, and we need to see, there we go, starting compilation, and now we have our dist folder, and there we go, we have our index.js file in here. Hi everyone, in this lesson I'm going to show you how you can extend recommended TypeScript configurations. First of all, I would like to ask you to go to this URL, github.com/tsconfig/basis. If you're not feeling like typing that, I've already included that in the resource files within our index.ts. Just go ahead and copy it and paste it in your favorite browser. Now, the idea behind this web page is that there is like a bunch of configurations that have been created by community members who contribute to this TypeScript project. Now, these are actually centralized recommendations. What that actually means is that if you want to make sure that your project, the configuration for your TypeScript project, upholds the standards that other developers use as well, then you could use one of these recommendations. Now, there are a lot of benefits for using these kind of recommendations. Some of the most important ones are like you can have a universal config file. You can have a configuration file for every use case. There is going to be a community support when you run into issues. And you will also be able to understand how other TS developers' code is compiled. And if we take a look at this, we can see that there is a recommended, which we are going to use in this lecture. There is a configuration, tsconfig.json file for a create React app. We have for testing, we have for Dino, Docusaurus, Ember, ESM, Next.js, and then we have another one for Next.js as well. We have Node LTS plus CSM plus strict test. And we have a lot of them, and you can even go ahead and modify, and based on specific node versions for backward compatibility, you can use, for example, Node 10, Node 12, Node 14, Node 16. So there is like a lot of options from which you can use. We also have Nuxt, React Native, Remix, which is really, really interesting, and a lot more. So what we're going to do is we're going to select, now depending on your project, you're going to select one of these. Since I'm not actually working like this is not like a project, like a big project. This is just one lesson that I'm going to show you how you can use these for your next projects. For example, you are a React developer and you're looking to incorporate TypeScript into your React projects. You can use this tsconfig file. I'm just going to right click on it, open it in the in another tab, and what you're going to do is you're going to use all of this. Now, we're not going to copy paste it. We are going to install all of this, and I'm going to show you how that works. So what we're going to do is we're going to take a look at this recommended, and you can see we already have our target, module system, strict mode, ES module interop, lib check. We have for force consistent casing in file names. Now, this is really, really important, especially when creating React projects, because if consisting casing in file names, it is not paid attention to, it could actually alter how the React app works. So you need to have this on, and I believe it is set to true for React projects as well. So if I just open that up, open this up in this one, and there we go, force consistent casing in file names set to true, because this has the potential to alter how a React app works. Anyway, I'm not going to jump into that. What we're going to do is we're going to take a look at how we can use this, not just like copy pasting it into VS Code, how we can install all of those recommended settings. And then by the end of this lesson, I'm going to do a very simple check to make sure all of these settings, they have been installed correctly. First of all, let's comment that part out. I'm going to come here. Let's jump into the terminal. I'm going to do npm install. And then what we're going to do is we need to install the recommended configurations as a dev dependency. Why dev dependency? Because depending on our project, the needs of the configuration, the need for TypeScript is going to vary vastly. So we don't want to install that globally. We want to install that locally within our projects. And there is another reason for this as well, that the entire idea behind TypeScript is for projects that are medium to large scale, like for production grade projects. And what you do when you're working on these kind of projects is that you're not alone. There is like a team working, and this having a uniform set of configurations is gonna make it a lot easier for all team members to collaborate and to be able to understand one another's code and actually contribute to one project. So we are going to install it locally for this specific project as a dev dependency, and for another project you can install this, or you can install another kind of for example configurations that you want. So let's go ahead and let's install that. I'm going to do save-dev at tsconfig / Now, which one do we want to install? We want to install the recommended. Here it is, recommended.json. So I'm just going to say recommended. There we go. And there is actually, it actually shows you how you can install that. npm install save-dev tsconfig recommended. We could have just copied that. Let's hit install, and it is going to install that for us. And the next thing that I'm going to do is I'm going to go ahead and extend these settings into our tsconfig, current tsconfig. So what I'm going to do is on top of our tsconfig file, outside of this compiler option, right here, I'm going to hit an enter. I'm going to say extends. And then we're going to add our tsconfig file. So add tsconfig /recommended, there we go, / tsconfig.json. Let's save that. Let's add in a comma. What seems to be the issue? Extends requires base. Compile tsconfig recommended tsconfig. Let's add that tsconfig.json. Let me take a look at that. We have installed that tsconfig / recommended. And now there we go, the error is gone. Basically, there was like one typo there. Cool. Since we have extended these recommendations, there are some properties, there are some settings that are going to be overlap. If I take a look at the recommended, we have our target ES 2015, we have our common JS. So what I'm going to do is I'm going to delete the ones that are duplicate. We have target ES 2016, there it is ES 2015, so I'm going to delete it from here. Module, I'm going to delete. Root dir, I'm going to delete. Let's go back one level, just zoom out. And then we do have the strict there, so I'm going to delete it from here. I'm going to delete this one as well. Force consistent. I'm going to delete that as well. All of these are really difficult to talk about. So what else do I want to delete? Yeah, I think that is it. So let me just tidy some stuff up. There we go. And let's save that. So everything is okay. Cool. And I've already added a star to this repo. So what you're going to do is, if you're logged into GitHub, just go ahead and just click on the star, just give it a star, right? And there we go. So we are done here. The only thing that I need to do is I need to check whether or not everything is working correctly. So we know that for this setting, the module format is common JS. So I need to export something very simply, and then we're going to see if the compiled code is in common JS format. Export, let course name. I'm going to say type is string, and let's pass in TS. And as soon as I save that, let's run our watch. And there we go. Let's jump here, and we can see that we have an export object, and this is the format for this is the module format for CommonJS. So we have been able to successfully extend recommended settings or whatever kind of settings that we want for our configurations, and it was successful. So that is it for this lesson. See you in the next one. So far, the way that we have compiled our TypeScript files into JavaScript files has been a multi-file compilation. That means that we have one JavaScript file for every TypeScript file. While this is the default compilation option for TypeScript, it has some advantages and some disadvantages. For example, in case we're working with Node.js, we can use the require function to concatenate all files, and the require syntax of TS works very well with that of Node.js. However, while working with the browser, it is a bit more difficult to load so many JavaScript files into the browser. This is going to make it extremely difficult working with front-end projects. Well, an advantage of multi-file compilation stems in production, where we, for the purposes of project maintainability and update, can just refer to one file for changes. But there is another method that is called a single file compilation. A single file compilation means that we take all of our TypeScript files and we compile them into, or bundle them into, one JavaScript file. And this single file compilation, it has its advantages and disadvantages. An advantage of single file compilation is that when we load that file to the browser, there's just one file that the browser has to work with, which means we are going to have fewer HTTP requests, which in return means that our application speed is going to enhance significantly. A drawback of single file compilation is in its maintainability. For example, if we want to bring changes into our app and our app is in production, all of the code has to be pushed again. But when at the end of the day, when it comes to front-end projects, we do prefer working with single file compilations. And since most of what TypeScript does is working with front-end projects, we need to know how single file compilation actually works. And to be able to do or come up with single file compilation and implement that, we need to have a third-party tool, which brings us to another drawback of single file compilation. And this is what basically holds a lot of people back from using single file compilation, because you're going to have more dependencies, and more dependencies means more trouble and more headache. However, this is an industry standard, so it is my job to teach you how this actually works. For the purposes of this course, we're going to use Webpack since it's extremely popular and it is extremely relevant. What Webpack does for us is it is going to bundle our code into one file, all of our TypeScript files into one JavaScript file, and it is going to serve it to the browser. And the browser is going to load just one file, therefore it's going to be a lot faster than loading a lot of files and making a lot of HTTP requests. So let's go ahead and let's see how we can install this Webpack. The way that you can, first off, I just showed you the website. You can go to webpack.js.org. And you can see that it basically, this diagram shows everything. We have all of these dependencies, we have all of our assets, and when we funnel it through Webpack, it is going to give us a .js file, .css file, .jpeg, and PNG. It's going to give us static assets. Let's go ahead and let's set that up in this lesson. First of all, what I'm going to do is I'm going to create an app directory within the source directory, and within the app directory I'm going to create a main uppercase main.ts file. The only thing that I want this main.ts file to do is export a function for me that is going to print hello. The function is not going to accept anything. The return type of the function is going to be string. Let's say return hello Webpack. Let's save that. And now what I'm going to do is within our TypeScript file, within our index.ts file, I'm going to import that. So let's go ahead and let's import our function, import. We want to import the print hello from from the main file within the app directory. Now, what I'm going to do is I'm going to jump into our terminal to install Webpack. npm install --save dev. Now, when I install Webpack, there are a couple of other things that I would like to install with Webpack as well. So the first thing that I'm going to install is going to be Webpack. Let's install Webpack CLI. And then we are going to need some sort of server that is going to run our application, that is going to serve our application to the browser. So I'm going to say Webpack dev server. So for everything is cool. And then I'm going to install a TS loader as well. Let's hit enter. And I'm going to jump into the package.json file. We're going to see our dependencies increase. It is going to take like a few seconds. For you, I'm sure it's going to take less time. and I'm just waiting. Then after the Webpack is installed, we need to create a configuration file for Webpack. You know what? I'm going to pause the video, and after the install is complete, I'm just going to come back. I don't want to waste your time. All right. It has been installed. Very cool. And if I take a look at here, we can see we have our Webpack, Webpack CLI, we have dev server, and here we have our TS loader. So everything is cool so far. Next up, I'm going to click in the directory, in the root directory in this TypeScript and Webpack, and I'm going to create a new file that is going to be webpack.js. Sorry, webpack.config.json. Webpack.config. Why did I say JSON? It has to be JS. This is not a JSON file. There we go. We have the Webpack icon. Now, where are we going to grab our settings or configurations? Now, what we're going to do is there is actually a website right here. What I'm going to do is I'm going to search for, within here, I'm going to search for guides. Let's hit enter. There we go. Let's click on guides. From guides, we are going to jump into TypeScript. There we go. Like a little bit, you have to come down here, and here is TypeScript. Just click on TypeScript, and I think I need to zoom in. So we have everything you need to know. TypeScript is a type superset. We know all of that, how you can install, basic setup. We have already done this TS loader, so we don't need that. What we're interested in is this webpack.config.js. I keep saying JSON. So what I'm going to do is I'm going to go ahead and I'm going to copy everything that is here. Let's just copy that. Let's come here. Let's paste that. I'm going to close our terminal. Let's save this. So far we know how all of most of these work. We have our require, which is going to import this path for us. We have our module.exports object that is going to have an entry. Now keep in mind that the entry is source index.ts. This is our entry right here. Where is the Webpack? Let me just close this, and I'm going to close this one as well. And then we have our module system. Within the module, we have some rules where we are going to test for the .ts file and .tsx file, which is for React. We're going to use our TS loader, and we're going to exclude node modules. Which files we're going to resolve? We're going to resolve TS, JS, as well as TSX, which is again for our React files. Then the output, keep in mind, the output name, file name is bundle.js. So if you have one TypeScript file, if you have 1,000 TypeScript files, all of them are going to be bundled. When compiled, they're going to be bundled into this file. And where is that file located? The directory name is dist. And we already have that file. That is going to be like bundle.js. So it's like a good indicator of what the name actually is. There isn't any option. If you remember, we installed this Webpack dev server. However, there is no option for that, so I need to add that manually. I'm going to say dev server. And for dev server, we need to assign what the flag is going to be, which is going to be static, where the directory is, directory. Path.join, and so the directory, I'm going to assign it as a public directory. All right. And then we are going to create that public directory as well. And I'm going to tell you why when I create that public directory. Cool. Because at the end of the day, what we want is we want this Webpack to serve our files to the browser. And I'm going to come back to that, so don't worry about it. Dir name, I'm going to call it public. These are common conventions, and I try to go by these so you have like a good understanding of what common conventions are. And we need to specify finally what the port is. I like to specify it as 1990. However, the default, in case you're wondering, is 8000. I'm just going to keep that comment there. There is one more thing that I would like to add here, and that is what I'm going to do is I'm going to add one more thing, and that is going to be how we are going to work with this project. Now, I am teaching you all of this. This certainly isn't a production environment. This is like a development environment, a testing or a development environment. And I need to tell this Webpack explicitly that this is a development environment. So right after the entry, I'm going to say mode development. So there are no confusion, there is no error, and there is nothing. All right, so everything is cool. Let's jump into our package.json file. And in here, I'm going to add another script that is going to run Webpack for us. Webpack. And the script is going to be Webpack itself. Let's save that. And I'm going to add another script for running the Webpack server. So I'm going to say dev Webpack serve. Currently, it is Webpack serve. So everything is cool, and let me just take a look at these settings. Everything looks awesome. Next up, I need to delete this JS file. We are not going to need it. And I'm going to create a public directory, public. Within the public directory, I'm going to add an index.html file. There we go. This is why we need our public directory, because no browser can work without an index.html file. And I'm going to call this TypeScript or TS and Webpack. Cool. Let's add our file script source, and it is going to be called bundle.js. We know that. And in here, I'm going to do an h1. That is going to say, hello, Webpack. I think everything is all right so far, right? Package.json, we have our watch, we have the Webpack, and we have the development server. And the only thing remaining is for us to jump into the terminal, clear everything. And in here, I'm going to say npm run dev. Let's run that and let's see what is going to happen for us. So we can see that it is serving our files. It did create for us a local host at 9090. All right. There is one error in our code because we haven't read this. So I'm going to say log print hello. We call this function, save that. And there we go. It just moved on. And if I come up here, we can see that the project is running at this host. So I'm going to hold control and I'm just going to click on it. And it is going to open it right here. And we can see our message there. But what about this log, that log that we had? Let me just reload the page. There we go. So I'm going to zoom in. We can see that we have our Webpack dev server on, server started. And we have waiting for signals from Webpack WDS, Webpack dev server. And here is our print statement, hello Webpack. And congratulations for setting up Webpack. That is it for this lecture. See you in the next one. Congratulations on completing this course. I'm really happy for you and I commend you on your hard work and dedication. I do wish you the best of luck in your future endeavors and see you in the next course.